Good evening, guys. 7:30. So let's continue. Now, if you can recall, yesterday we talked about basic stuff. We saw what do you mean by container? What is the requirement of a container? Why people are running after containers? Why containers are in boom these days? And why people are looking for Docker certified associates? In a sense, if they want to run their application in containerized form, they need to have someone to manage those containers, to convert their applications into containerized form, to put their or to run their applications into containers. And this is nothing but you. So you people will help the industry to make the application containerized. And that's the reason why we are continuing with all of these efforts. So we saw some basic stuff yesterday. Today we are going to go a little bit advanced more. We'll see how to create our custom images, how to deal with them, how to use the containers, how to start containers, how to stop the containers, how to publish ports on containers, how to use volumes, and so on and so forth. Many different things we are planning for today. So let's not waste time. Let's continue with the topic directly because we already have created ground yesterday, and I bet you all of you must have installed Docker on your machine, and it is working successfully. So please do not put any question today related to permissions or related to any Docker issues, because we now want to dive into Docker and we want to get the things directly with the Docker. Okay, we don't want to solve the Docker related issues. I hope you have spent enough time and probably everything is working fine on your machine. Okay, if you face any problem related to Docker installation, I think Google is your best friend. You just go and try to install it. It will take few minutes or few moments for you to fix the problem. And I guess it's working fine on you on your machine. So we'll continue directly with the next step. So we talked about images yesterday, the basic stuff at least. What the hell? So we talked about the basic stuff yesterday. What is the image and how the images will help us to run our applications into containerized form. We said that the Docker images are nothing but the package, or all of them are the packages where they will bring the application along with the dependencies, libraries, platform into one single unit. That unit is called as an image, and that unit will later be instantiated to start the application in containers. So containers are nothing but running instances of images. That's how you can get it. Now, yesterday we pulled some images and we saw that once you have those images, they bring different layers with them. I mean, when we are talking about the images are created by using layers. Every image will have different layers, and we already have seen that yesterday. I showed you how when we are creating an image, we'll split up into different layers behind the scene. And those layers are the ones which are kind of helping us to reuse the layers or to reuse the images for running multiple containers to create our custom images as well. So this is what we started yesterday. Now let us continue further and see how we can use those layered architectures or the layered approaches and to create our custom image today. So we have to create our custom images. We have to start digging around them. But even before we do this, we want to continue further and let's do some exercises on containers first, because unless we know enough about the containers, there is no point of talking about creating images, because when we start using containers, we'll face some problems, and to solve those problems, we can create our containers. So let us start doing that container stuff and see how we can turn containers into images, or how we can make use of those containers by building our custom images. We saw that yesterday a container is nothing but the running aspect or the running instance of an image. So this is an image where you are going to have idiots. So these are the containers where you are going to run the image or instructions in the image. Just give me a second, guys. These people are so idiot. So sorry. Can't imagine people advertise their horns like this. Anyways, so coming back to this one, so container is nothing but running aspect or the running instance of an image. So image contains all the instructions. So container contains one or more running processes. Those processes are created by following instructions which are there inside the images. So whatever instructions are there in the images, they will get executed, and those instructions will spawn the processes. So those processes will run inside the containers. So containers are nothing but the self-contained environments. Everything, whatever is needed for your application to run, it will find inside one single unit called as a container. And that's the beauty of running the applications in the containers. So whatever application is looking for, the libraries, binaries, platform, runtime, it will find every single thing within one single container. It wraps up the application into its own isolated box. The application running inside the container has no knowledge of other applications or processes that exist outside the container. I guess I mentioned that yesterday. So it seems like container one, which is running an application, would know only about the application one. For that container, for the entire application, for on that entire machine, it is the only process which is running. That's it. The container one doesn't know anything about the container two. So that's the beauty of running container into isolated environment. And probably if you can recall, we said that yesterday that to do this job, there are three things which will help you to do this. One is namespace, second one is the C group, and third one is something called as a union file FS or UFS. So namespaces are going to isolate all the environments amongst those different containers. So that's how the namespaces, which is Linux Funda, will help us to run applications into different isolated environments called as containers. A container cannot modify the image from which it is created. And the reason is very simple. If you can recall something, this diagram, I said that when you're talking about the image is going to have different layers. So you see that this is an image which contains layer 1, 2, 3, and 4. And when you create a container will create one more layer on top of this layer. So container cannot modify these layers. Container cannot modify the image. Container creates one more layer above the different layers available in the image, and that layer is where it is going to write the stuff. So when you delete a container, the image will stay as it is, but the writable layer will be deleted, and that's the container will delete whatever it has created inside that writable layer. So remember, container cannot modify the image in whatsoever form. It is not possible for a container to modify the image. It consists of application code, whatever application you want to run inside it. The dependencies are nothing but the libraries or binaries which are needed for running your applications. Networking, whatever networking properties your application is looking for, like bridge network, host network, and so on and so forth. And finally, different volumes so that the container can persist the data outside the container. I guess I mentioned yesterday, containers are immutable. When I say containers are immutable, that container simply means, the container cannot add anything into its own stuff. It cannot save the data. So the data will be saved outside the container inside something called as volumes. So I gave you a complete picture of container yesterday. Now today we have to dig around this and we have to manage different containers, and we'll see what are the different operations are possible for us and how we can start looking at this from a different angle. So we'll see list of running containers. We saw that yesterday as well. We'll create a container today, rather not once, many times. We'll start a container and stop the container when needed, when we don't need that. We run the container in a started form. We'll stop the container, running container, and we'll restart the container. And other than that, we are going to do hell lot of other things. They are the starting point for us. So let us not waste time. Let's go back and let's start doing the stuff practically. Okay. So I'm expecting that you already are ready with the Docker environment, and probably we all can start writing the code together. Okay. See what and how we can do the job. Okay. Okay, so let us start here, and let me go through first the same command which we have seen yesterday. That's docker image ls. I want to see which images have I created or have I downloaded from Docker Hub. Seems like there is a Hello World, Nginx, Alpine, Mongo, and MySQL. That's it. Now we'll start with a very simple example. So I want to start with that hello world one more time, just to start the feeling that we are now going to start creating containers. I'm going to start with the simplest and the most basic container, that is the hello world container. We know how to create the container. We see Docker container ls will show me all the running instances of containers. It will show only running instances, which means if there are few containers which are stopped or maybe which are created only or exited, they will not be shown here. For them, we'll have to use -a for all. So show all the containers right now. So on my machine, I have only one container which is running, which is having the Mongo inside it. So this is the Mongo's container for me. It's okay. Now I want to start with one container for that hello world. How do I do that? To do this, I'm going to start with Docker. If you can recall the command, Docker container create. Create is the command with which we can create a new container. But you know what? When I say create the container, the create will simply create the container. It will not start. Most of the times when we want to create the containers, the basic requirement of creating a container is to start running that instance, or to start that container so that it can run our application inside that logical environment or unified environment. So my basic requirement behind creating a container is to start running the application. So creating container will not be suffice. Here we have to run the application or run the container as well. So instead of saying like create and start, I want to take a shortcut and we'll say that something like run command we already have seen yesterday. So Docker container run and name of your image. Now hello world is the name of my image. Now what happens here is when you say Docker container run hello world, it will create the container. The container will run, and while running the container, it shows whatever the output the container or the application inside the container has logged on the console. So whatever is there, it will show you here. Basic hello world application is running. That means everything is working fine. I hope we already have talked about that yesterday. Now the container got exited because the container was supposed to perform only one job, and that is to execute that application. Other than that, it will do nothing. Most of the times you will see that containers will have only one single job to run. What happens is when we are using the operating system on our machine, let's say this is Linux or Mac or Windows we are using, probably there is an operating system, means it will just wait for me to do something. For example, when I start my machine, it shows up a login prompt. I log in with my credentials and it shows me the desktop, and it will wait for me to do something. I mean, I'll have to open, let's say, Explorer. I have to double click on icon to launch an application. I have to go to command prompt and type the commands. So this is an operating system. It will wait for me to do something. But when we talk about the containers by far are different things than your normal machine or normal operating system or normal virtual machine. Virtual machine will also run an operating system, and it will just wait for me to do something because that's an operating system. Containers, on the other hand, will perform only one job, one and only one job. That's it. That is the job which we are going to configure later into our custom image. So whenever we are talking about something like this, talking about the container like this, the containers are going to perform only one job. Always remember, containers are going to perform only one job, and that job will kind of execute here, and then whatever is the output you will see, and the container will exit. What is the state of that container? I don't know. Let's check this out. When I say container ls, it shows my Mongo container, but nowhere I see that hello world. So I'm going to use -a, and a tells me that yes, this container was created. I see that this container has got created a minute before. It must have printed the output of that command which it was supposed to execute, and then after that there is nothing to do. I mean, that container has nothing to do, and that's the reason the container has exited. So container is a very short-lived application. I mean, whenever it starts, it executes the command, whatever it is meant for, and then when the command is done, whenever the command is exited, it also gets exited. So that's how the containers will do only one and only one job. Okay, so I'm gonna go back here, and it seems like when we create the containers, container will have a kind of a funny name, like kind Richie. What's the meaning of that? Now, when you do not supply the name, by default, containers will get name associated with them. I don't want to do that. I want to assign my own name. How do I do that? Use minus name at the time of running a container. I'll show you that. But before this, I want to delete this container. So again, I'm going to say Docker container rm. It's 90 is the ID with which I can identify this. When I say 90, the container with that ID starting with 90 will get deleted, and you see that now I'm having only Mongo left. That's it. Okay, so once created, Prabal, you cannot change anything in that container, not even a name. You cannot add anything into container. You cannot modify the container. You can't do anything there. So once created, the containers is always going to be immutable. So it can't do anything there. Okay. Yes, Shubham, I'm going to send those commands today. Yesterday, I was waiting for all of you to be there, and now this is finalized. I mean, this is the final team right now for next couple of days. Once we are done today, I'm going to share all the commands there, starting from today. Okay, don't worry. So we are here now. We want to get repeat the last command. Which last command? Container ls minus a. That is the one which is going to give me the list of all containers, right? So probably this is the list of containers, and rm command is the one which is going to delete the container. I'll show you that one more time. But before that, I need to create a container. I'm going to create the container again for hello world. But this time, when I'm going to create a container, I want to use minus minus name, so that I will not get the funny name there. So I'm going to say this is my container, as simple as that. So when I say minus minus name, the container will honor my name, and instead of just using some funny name, I'm going to use this name. Absolutely, Shravan. This has to be a unique name. You cannot run multiple containers with the same name. That's again one of the requirements there. So now if I say docker container ls, you see that it's not going to show up ls minus a. You see that now the container has been created with my container as a name. Now I don't have to even think about that ID because I know the name of it. I'm going to use the command rm for remove. Which container I want to remove? The container having a name, my container, and the my container gets deleted. So probably when I say ls minus a, you see that the container got deleted. Now, what happens here is most of the times when the container is supposed to do only one job, see the workflow again. I want to execute that hello world by running that container by using the run command. Minus minus name will assign a name. And when you run this command, it will show the output. That's it, But after that, when I, just done with executing this, it unnecessarily stays there. It goes in the exited state, but it unnecessarily stays on my machine. And then I have to go back and then I have to delete that container manually. I'll show you one more time. See the problem. So I'm going to create the container got created. It got executed that application it was meant for. And now it must have gone in the exited state. I'll have to first check ls minus la, and then it shows, yeah, that has gone into the exited state. Now I have to manually delete this because I don't want to keep those exited containers on my machine unnecessarily, So how do I fix this problem, or how do I remove those containers? We saw that. We are going to use the same command, docker container rm, name is my container. That's it. So this is the way we are doing the job. Container create and then container remove. This is something which we are doing it manually. But what if I tell you that I can run a container, and once it is done executing the command, it will automatically delete itself? So I think that will solve my problem, or that will make my life a little bit easier. I don't have to go there, look at the ls minus a, then see whether it is exited. And if it is exited, then I have to use minus command, rm command. So instead of this, I can instruct my container to remove itself when it is done with the job. How do I do that? With this, for that, I'm going to use the command minus minus rm. This is the switch we are going to use here. See, container run means it is going to run the container. Which container? A container with the image hello world. Now, while running the container, it is going to assign a unique name, that is my container. And with minus minus rm, I'm telling the container that when it is done, please delete itself. Don't keep exited containers on my machine. Those are not of any use. So I'm going to delete that immediately. See what happens now. See the difference now. So when I say docker container run minus minus name, my container minus minus rm hello world, C must have done its job. And if I go back to ls minus la, you see that it's not showing up in an exited state. Why is it not showing up in an exited state? The reason is very simple. I said that once you are done, and once you say I'm going to exit now, instead of just going to exit, I want you to get removed from my machine. So minus minus rm, and that is going to delete the container automatically. I don't have to literally go every single time and delete it manually. So hopefully this is the way you are going to simplify your process or simplify your life. The container's life cycle. So container life cycle will start with run and automatically will finish by using this minus minus rm. When you say minus minus rm internally, when it get exited, it uses the rm command to remove itself. That's the beauty of using minus minus rm. So generally, and most of the times, this is what I'm going to prefer. Just a sec. Let me create one more desktop right here, and I'm going to create a new directory, and I'll start sharing, or I'll start putting all the all the commands inside some log files. So maybe I'm going to use code mm, cd slash volume slash data slash where should I go for? Okay, Sunbeam. We are in 2021 workshop, and I'm going to create a new directory for you. That's Docker workshop we are in, and right inside this. Okay, so this is where we are on the second day. So day two, sorry, day two, and right inside this, I'm going to put all the commands so I can share you this later today. Okay, so this is where I'm going to use commands.md. Do I have MD Markdown? Just a second. This is the newer machine, so I don't know whether I've installed this or not. So Markdown, Markdown. Yes, Markdown all one and preview. That's it. So I just need those two extensions, and we'll start coming back here and start adding all those commands. So the commands which we are going to use right here. So I'm going to use the bash version of it or sh version of it. This is not for you. You just have to look at the PDF file, which I'm going to share later. So just a sec. If it is working, that will be wonderful. Yeah, this is what I'm going to share with you. So you don't have to worry about that bash and the other style there. This is just for me so that I can format it. So the first command we saw related to the images. Sorry, I'm sorry. These are all the commands we already have looked at for the images version or for the images part. So this is the Docker image ls. That's the first command. Docker image rm command, or maybe pull command. Let's say pull hello world, for example. We have done. Okay, one more. Let's say pull. We are done with that, and once we are done with this, we are going to say rm hello world. So that's how we are going to do the job. Okay, so probably it will help you to start doing the stuff. I should. Just a sec. I'll make your life a little bit easier now, guys. So what I'm going to do here is this. I'm going to start running my server. So it will be easy for you to share my code, and you can copy and paste those commands. Okay. So code explorer, and I'm going to say node server minus p, and this is the directory. So hopefully that will solve your problem. Just a moment. Okay, course. Which course are you in? Docker Kubernetes. Okay. So doc. So guys, I think better you go back, and it's already there. Okay. You go to that student portal again. So I would want you to go to student portal and just look at this one more time. I'll show you where you can look at and how you will do this. Say this is Docker day 2. So what I want you to do here is, now you can go back to the student portal. So I'm going to go for my user. You go with your users. Okay. I'm going to use my credentials. And when you log in with your credentials, you go back to the online session. You must have seen that earlier. Now, in that online session, those who are new, for them, in that online session, you will see an option here to click on that code. This is an action. So you click on that code, and you will see all the commands that I'm going to put inside this one. So you can directly copy and paste that command there. It will be easy for you to do the job. you know. So as and when I add the command, then a sheet is not visible to you. Refresh this one more time. Hopefully that will be visible. Log out and visible again. It is visible. I hope I added that. Okay, wait. Someone will add that into your portal. Who's that? Rahul sir, can you please add that token for all the other batches, all of our full-time batches, please? Don't worry, full-time batches you will see there.
Sir, I will add in 2 minutes.
Yes, please add them others. All those KDFI, again, that's DBDA people and DMC people, just wait for some time. You will see them in your own portal. Okay, I'm talking about those who already are maybe the part of Docker or in this group, the WhatsApp group. Okay, for them you can do it. Okay, make sure that the Docker is running, Rishabh, because unless the Docker is running, you cannot do anything. If you're on Windows, then run the Docker desktop, and if you're on Linux, start the Docker service. Okay. Yes, you will see them in a minute. So this is how we can literally copy and paste the commands. Okay, I'll make your life a little bit simpler with that. Anyways, now we'll go for the other part of the world, and there are so many commands. We will start working together. So this is container related commands, you know. So the very first command we saw yesterday, it was create. So create container with the name hello world, as simple as that. I'm sorry, hello world. Now when we are creating a container, so this is the container command again, and inside that container command, so probably I want to see container ls and ls minus l. Both these commands are going to do similar job. The only difference is ls is going to show you only running containers. Ls minus a will show you all containers, irrespective of whether they are running, exited, started, created, and stopped. Anyway, so here we are. I'm going to say rm and container id. So container ID or container name, whichever you want to go for, both of them will work here. Okay, now when we are creating a container, we have a shortcut. I mean, when we are creating a container, we have to start that, you know. So again, container ID and container name, we have to start the container. And once it is started, I think you want to stop it. You can say stop that container as well. And then you can remove the container. So this is how we will do the job. Now, when we are creating a container, we have a shortcut. We saw that earlier today, and we saw that this is the command that we were using earlier. With run, you can also say minus minus name for setting up the name. I'll say this is going to be my container, you know. And along with this, you can also use minus minus rm. So this is minus minus rm that is going to do the job of removing itself after you are done with this. Docker create and Docker pull, both of them are two different. Docker create is the command for creating a container, and Docker pull is not there in the container. Docker pull is for image. You see that pull is for image. You can download that image from the Docker hub. Okay. In Windows, it takes too much time to run a container image ls command. Can't help. That's Windows, Kalpesh. Can't help. That's container. That's image. You know, that's a Windows one. Can't help. Okay. So probably now I'll continue with this. Rishabh, in that case, use sudo version, sudo docker and blah, blah, blah. Those who are getting that issue, use the sudo, and then you can do all of this stuff. Okay. Okay, so now let's continue further and see the way we are going to deal with that container. Okay. Harshit, why Docker has provided two commands for the same purpose? Docker pull hello world. Very good. Thanks for asking that question. I'm going to go back to the hub.docker.com, and if you search for any image there, for example, if I search for, let's say, Nginx, the one we are going to use in few minutes, I'm sorry, Nginx. So if I use this command, Docker shows you the command is Docker pull Nginx. This is the older command. Newer command is Docker image pull hello world. So this is the older command. Stop using these commands now, because sooner or later Docker is going to deprecate those commands. They are still there, they are still supported, but I don't know at what time Docker is going to deprecate them. So it's better use the newer commands, and newer commands are a little bit simpler to use, simpler to understand. See, if you want to list out something like list out image or list out container, ls is the command. If you want to, download something, pull is the command. If you want to remove anything, remove image or remove container, rm is the command. So it's better you can just use the later command or the better commands, or you can say the newer commands. It will make your life a little bit easier. Okay, that's the reason why I'm using the newer command. I'm not talking about the older commands. These are the older commands there. Okay, so as and when I update it, you see that the things are getting updated. Just copy and paste and run on your machine. Okay, enough. So I'm going to go back to my home directory so I can use that entire space available. Okay, let me see where I was. I have created that container, and probably I showed you the container, it will remove itself. So we have reached to the command where we can remove the container automatically by using minus minus or rm command. Okay, now the container got created, container has executed the job, and container already got exited. What's now? Now see what I'm going to show you. This is very important stuff and very different than what you have done earlier. Imagine that you are running a Linux on a virtual machine. I showed you that yesterday, running that inside my VM, inside my virtual machine like VMware, and it was a complete full operating system. Similar operating system is already given inside an image called as Alpine. Alpine is the smallest Linux. See, 5.58 MB. There is Ubuntu as well. So if I say pull Ubuntu, I can download that Ubuntu, but this is not the Ubuntu that you are installing on your machine. This is the this is the containerized version. I'm sorry, Ubuntu. There's a spelling mistake. So pull Ubuntu. So this is not the full version of Ubuntu. This is the containerized Ubuntu, or this is the Ubuntu image. It is going to run the Ubuntu inside a container. Full image or full Ubuntu, it goes almost like few GBs, 1.26 GB or something. But if you use the containerized Ubuntu, where is it? Here it is. It's hardly 72.9 MB. Okay, so this is again the Linux. This is also a Linux. This is the smallest Linux, 5.58, and this is the Ubuntu, the one which you are using on your machine. Few of you are using on your machine. Now I want to start this Ubuntu. How do I do that? To do this, see what I'm going to show you here. You can start Ubuntu or you can start Alpine. Both of them are simply, the Linux versions or Linux distros. I'm going to start both of them side by side or one by one. We'll start with Ubuntu because most of you are familiar with this command. So Docker, I'm going to say create the container. This time I'm going to assign a name called as Ubuntu. See, this is the name Ubuntu for the container. I want that container not to remove itself. I want that to stay there once I'm done with it. And what am I going to do? Nothing. I'm going to say this is the Ubuntu. I'm sorry, we forgot to say run. So here we want to say container run and name Ubuntu. So name is Ubuntu, and this name for container is Ubuntu, and this is the name of my image. Okay, so I'll put this command here. It will be easy for you to copy and paste. And if I look at my containers, so container ls, you see that Ubuntu started and it automatically got exited. I mean, what's going on? I started the Ubuntu. It should have waited for me to pass the output, right? Pass the input and show me the output. But it doesn't do that. I mean, it simply creates the container and then it simply exits. Because if you can recall what is the meaning of a container, I said that too many times now. Container is meant for doing one and only one job. Now, what this Ubuntu is doing, let me go back and search for this or see what that Ubuntu is doing. To do this, I'm again going to go back to the, hub.docker.com. And right inside this, I'm going to search for Ubuntu, the image which I downloaded just now. And if I look at that Ubuntu image, see what it is doing. Right now, you don't have to understand what I'm showing you right now, but still just see what does it do. This is a Docker file. We are going to see that later today, but towards the end of it, you see the last command. So it is meant for executing only one command, /bin/bash. Bash is nothing but the command prompt. That's it. So probably when we talk about something like this, yes, Docker PS is also old, Prabal. We use Docker container ls instead of using PS. PS is old. PS and PS-A. PS stands for processors. Docker has changed into the container commands. Use container ls instead of using PS. Don't know when the PS is going to get deprecated, so it's better you can do it. Okay, so that's fine. Yes, Shavan, that's okay. So when we are talking about this, I think it is meant for executing the bash, and that's what you see here. I wanted to show you in both the cases. This is the last command which is supposed to get executed, and you can see that right here. This has executed the command bash and it has exited. Okay, now that simply means, let me just go back here and show you what exactly is the problem and how do I solve the problem here. So let's imagine that I am creating a container here, container for Ubuntu. So this is my Ubuntu image. Let's say this Ubuntu image has got all the stuff inside the Ubuntu, and there is a directory bin, and inside that there is a command, there is a bash, or this is the shell, bash shell, born again shell. I use this image and created a container inside it. Now the container is supposed to execute only one command, and this command is bash. So it is going to create a process. This process is going to execute the bash command, bin bash, and then it will do nothing. It will just execute. And once it is done, it will say, I am done, and then it exits. That's it. It exits. It does nothing. It just executes that bash command and it does nothing. I'll show you one more time. Instead of running the bash command, see, instead of running the bash command, this is the command it is supposed to execute. But instead of running the bash command, I may say while running the container, listen to me very carefully. Docker container run means it will run a container. It will add all the parameters you are supposed to add, like name, rm, and so on and so forth. This is the name of the image. And then I can add a command, let's say date. Now, what happens here is, this is generally called as the entry point command. Entry point command, in a sense, this is the command which will get executed when the container starts. I can override this. I can say, no, don't execute bash, execute my command instead, date. So if I say date, see what happens now. Okay, this seems like I cannot run multiple containers with the same name. I told you that earlier. There is an error. It says conflict. What is a conflict? The conflict says container name Ubuntu already exists inside this one. Not a big deal. I'm going to delete that first. You know how to delete a container, or we can use minus minus rm. I'll do that for now, and then we'll remove that command later. So I'm going to say container container rm. What's the name? Ubuntu. Okay, so now there is guaranteed no container running with that name, Ubuntu. I'm going to use minus minus for now because I just want to execute only one command, and that is date. See what I'm trying to say you here. Probably when I execute this command, the command goes like this. This is the Docker. This is the main command. All these commands are related to the container. So this is container. This is the command run. Then you have got different parameters. Not interested in the params right now. Then you have got the image name rather, image name. And then if you are specifying something like the command, this command will get executed automatically when the container starts. So if you do not specify this command at the end, by default, it is going to execute the command it is meant for. So if I look at this one, it is meant for executing /bin/bash. But if I say, hey, don't execute that, execute my command instead, it is going to override the entry point command. See what happens now. If I use this command, I'll first copy this command and we'll put that right inside this one. So it will be easy for you to do this job along with me. So when I say enter, it creates the container, it executes the date command, it shows me the date inside that container. It is the UTC time zone. That's the reason it is saying 2 o'clock, 2:39. It's UTC time zone. Right now it is so maybe it's 2010, but it is saying 14:39. It's because of the UTC time zone. So important stuff here is the date command got executed instead of running the bash command. And this is the way we can override the entry point command. This is the way we are saying we are overriding the entry point command. The entry point command is always given at the end of your Docker file. We are going to see that later, but this is the entry point command. That is something like a bin/bash. If you don't do anything, by default is going to execute it. But if you say, no, execute date, it is going to execute that date for you. See, I'm going to say ls instead of saying date. I can say ls minus l, for example. I'm sorry, ls minus l, for example. And it is going to show me all the files and directories within that container. You see that? This is executing my command instead of doing nothing, or instead of executing that bash command. So again, Remember, this is the format. Docker is the main command. Container, I'm so sorry, container, and a container is going to execute or is going to run a new container. So run means run a new container. This is list of parameters. This is the image from which the container is going to create, and this is the entry point command. If you do not pass the command, by default it is going to execute the entry point command there. Okay, so this is the way we can do it. Tushar, bin bash is the shell command. This is the Linux command, or this is the Linux, which is going to give you the shell. This is the shell, what you see here. In Windows, it is called as a CMD. So Windows CMD is nothing but Linux shell. It gives me the shell there. Okay. So again, if I do not pass any command, it is supposed to execute the bash command. The bash command will do nothing because there is no one to pass the input for. This is the shell. This is again, I mean, it's a Z shell right now. So if I say echo dollar $shell, it will tell me which shell am I using. I am a big fan of a ZSH or ZSH. That's the reason I'm using ZSH here. But if you run that on Ubuntu, for example, Ubuntu say that the current shell is called as a bash. So currently in Ubuntu, if you are running that on your machine, then it is going to run the same command bash, but it will wait for your input. And when you pass the input, when you pass the command, it is going to give you the output of that command. That's it. But here it is going to execute that bash, whatever bash or whatever shell it is going to execute, and it will do nothing because it is not accepting any command from you. Now watch what I'm trying to show you. It's very important to understand this. So I'm going to create a new page here and see what happens here. So when you say this is the container, now imagine that the container has got created. You know, the container is about to start that command. This is the container, by the way. And container has got this bash here. You know, this is the bash. Let me use different colors so you can understand where we are going to run this command now. This is inside the container, and this is something like /bin/bash. /bin/bash means it is a shell. A shell is supposed to get the input from user and supposed to execute the command and supposed to give me the output. Because there is no one to pass the command to that bash, it executes and then it exits because it has nothing to do at that time. That's the reason it executes and it does nothing and it just exits. So what I'm going to do right now is this. Watch this, what I'm going to do right now. So you see this is the container. I am going to go back onto my machine now. I mean, this is my machine, by the way. The container is running inside my machine, of course. On my machine, I have got my shell. You can call it as command line, or maybe you can say CMD, or you can say bash, or you can say sh on your machine, where you see the command prompt like this. And what I want to say here is, when the container starts, I want this command interpreter to connect to that bash, and whatever command I'll pass here, I want to pass it to this particular bash. Means I want to go inside the container and then I want to run the command inside the container. To do this, I'm going to run the same command. This time I will not use --rm. I want that to stay there. Along with this, I'm going to pass one -i for interactive and t for teletype. Teletype means it is going to give me the command prompt, the one which I'm showing you here, command prompt of that container. And I for interactive. Interactive means I'm asking that container, don't do anything on your own, accept my command instead. I'm going to interact with you. So I for interactive, T for teletype. So this is the command that I'm going to execute now. Watch what happens. I'm going to go back here. I'll put that on your side so you can copy and paste that command and execute this along with me. When you execute this command, it starts the container, and automatically all of you running this command will notice it shows you that you are logged in as root @ some unique identifier. This unique identifier is of your container, you know. So where are you right now? You are now inside the container. You have gone inside the container, and henceforth, whatever command you are going to execute will get executed inside the container, not on your machine. For example, if I run one more shell on top, side by side like this, I'm on my machine. You see the container, the command prompt changes. This is my machine's command prompt. So if I say ls, this is showing me all my directories, all my folders which are there on my machine. But here, if I say ls, you see that it shows me completely different picture, because This command ls is getting executed inside the container. Outside that container, what you see is nothing but the Mac, and inside the container, what is this? This container is created for Ubuntu. So it could be Mac, it could be Windows, or it could be anything here. But be inside the container, you will see an Ubuntu. And that's the reason when I say ls, the command is going to get executed inside the container, and it's going to show me all the content, all the files and directories of that container. May I get a confirmation, guys, if you're getting, okay, or if all of you are getting the same output, right? You should see something like root at the rate some ID. And when you use the command, though you are on Windows, you still can run now the Linux commands because you are now inside a container. So whatever you do here will get executed inside the container. That's right. You can, of course, you can say uname there, whatever commands. You can say uname -a. It will tell you that you are running on Linux. This is the Linux, not Windows. Even if you are running this on Windows, you still will see this is the command. Date command, ls command, whatever, maybe mkdir command. I'm going to create a new directory here. Let's say my directory, and so on and so forth. So this is the way you should go inside the container. So what has happened now? I have gone inside the container by using two parameters, -i -t. I mean, you may say -i -t like this, or you can combine them together and say -it. It's not it means it, it's it. It's I for interactive, T for teletype. So how do I come out of it then? Okay, if you want to come out of it, use the exit command. And you see, I'm done with that. I'm going to execute this. I'm just going to get exited. And see, I'm back on my Mac. So if I say docker container ls and see the status, you will see that when I came out of it, the job of that bash is over. Again, if I say ls -a, you see that the container got exited. The container got exited because the job of it is done. What has happened? I started that container. I said, hey, container, wait. I want to execute some commands with you. Using -it, I grabbed its bash. I executed a few commands. And when I'm done, I said exit. When I say exit, this exit command was given to that bash. When I say it has given to the bash, exit bash means this command or this bash is done. Because it is done, there is nothing left for this container to do. It's like it has lived its life fully, and now there is nothing to do for that container. And that's the reason it is now going to exit. Because it is now going to exit, you see that this exit command and this bash exit is telling me the container also got exited because there is nothing to do for that container after that bash command is done. Robin, containers are immutable. How can we change something inside it? Wait, I'm going to come back to that point. Just keep your question on hold for some time. I'll repeat myself. What do you mean by immutable, and what is the real meaning of that container in a minute? Okay, just hold on for some time. Mayur, whatever operations we perform here, like the operating system directory and blah 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 blah, will be executed in the running or in the writable area of the container. Absolutely right. All of these commands will get executed. You will see the output and all of that stuff. It's just because you are now inside that writable area of that image or writable area of that container, which is created on top of the images there. Absolutely right. How do we exit? Use the exit command. That's it. Robin, was that bin bash command is coming from the Docker file from Ubuntu image? Yes, it's coming from the, it's not coming from the Docker file, it's coming from the Ubuntu, because Ubuntu provides that bash, and the Docker, that image which we are using here to create a container is of Ubuntu. So Ubuntu provides that bash. So bash is given by Ubuntu. Okay. Okay. Vaibhav, -id command in the image is specific. I mean, it works for all images. Yes, it works for all images. I for interactive, T for teletype. I'm asking every image, for example, don't do anything on your own. Give me your control. I'm going to control you. That's how we are going to do it. Okay. And if you do not specify -it, you will be able to do nothing inside this. Okay. Now I'm hoping everyone can see one container running with exited state. Okay. Now this is exited. Can I start that container again, which is already exited? The answer is true. We can. How do I do this? To do this, I'm going to say again, docker container. I should have gone for, I already have gone for this. Very good. So docker container start. Again, I can restart it or maybe you can say start the existing container again. So I can say docker container start. What is the name? The Ubuntu is the name, or we can use an ID as well. You see that I started the container, and if I look at the docker container ls minus a, look, it is now saying up for 4 seconds. It is now not exiting. It is saying it is kind of working. It's kind of running. What has happened? I mean, here I said now start again. When I say start again, the Ubuntu container has started. The bin bash is running behind the scene because I passed that minus IT last time. Remember, I used that minus IT, and because of that, now it is waiting for me to get the command prompt in my hands and pass the commands here. And that's the reason why it is up from 4 seconds. If I use this command, I see that the command is running now. So use this command docker container start Ubuntu, and you will notice that your container is now restarted its life cycle. So now it is started, now it is running. But now the question is, how do I go inside it? Because last time I went inside it by using that run command and passing the IT there. Now how do I do it now? I can't use the run command again, because if I go for a run again, it is going to create a new container, not the container which is started right now. So how do I do that? To do this, I'm going to use one more command now. The command here is docker container. Remember, I said that docker container is going to give me all the different commands for managing your containers. There is a ls command, rm command, run command, create command, start command, stop command. Similarly, there is one more command called as exec, stands for execute. So all I'm saying now, I see a container is up and running right now. And when I say up and running, probably I can go inside that container and I can execute the command. I can say execute. I'll show you two ways. One is the simpler, not simpler, but one is the kind of attached mode, and the other one is a detached mode. What do you mean by that? Watch this. First, watch this and do it on your own a minute later. See this. I have a container which is right now in up and running state. I want to connect to that container. Means this container is connected. This container is running. The bash is not exited. The bash is running. Now I'm going to say container attach. Attach is the command, which means I'm going to attach to that container. When I say attach, my command prompt gets attached to the bash. What do you mean by that? Check this out. Container Ubuntu. When I say attach to Ubuntu, I see that this is the Ubuntu, and this is where I am again going back inside the bash, and I can again execute all my commands. Remember, last time I created the directory, my directory, it is still there. So probably I can see ls again. I'm executing all these commands right inside the container. Guys, can you execute this command again and tell me whether it is working for you? So you see the docker container attach command is the way with which you can go inside the container one more time, and probably you can again start doing all that stuff you have created earlier. Do this again, create a new directory, mkdir, my directory 2. And make sure that you already can see that directory here. Again, say exit. When you say exit, you can check that docker container ls minus a, it will exit itself. It will get exited because I attached myself to the bash, meaning whatever command I will execute, those commands will be passed to the bash. When I say exit, what is going to get exited? The bash is going to get exited. So what happens here is, whatever commands you are going to execute here, the bash is going to execute for you. So bash is going to execute for you. So if I say, hey, now maybe instead of saying exit, so this is the command, this is the bash. And if I say something like a date command, this date command will be executed and will be given the output right here. So again, I'll have to start my container first, and then I'll have to attach. When I say attach, and if I say date, this date command is going to get executed by bash and will give me the output. When I say ls command, it will execute the ls command and will show me the output, so on and so forth. Now when I say exit command, this exit command will exit the only process which is running, and that's the reason the container will also exit. So This is the attach command. Attach command once get exited, you will see the container gets exited. The simple reason behind this is because the only process running inside the container is exiting, means there is nothing left for that container to do. Because the container has nothing to do, container will end its life. End its life in a sense that container will get exited. That's it. So container will live till the command inside the container will live. When the command inside the container exits, container will also exit. As simple as that. Container can execute only one process, and that is the one which is called as the entry point process. I hope the things are getting clear to everyone. Prabal didn't understand why we go inside the run, it exits immediately. When we say start, it keeps running. There is a reason behind this. The reason behind this is because you didn't see that last time, I guess, or you missed one parameter here. Maybe I mentioned that right here. It is just because of this IT here. So if you do not use that IT, you will see nothing sort of this is going to happen. Okay, so probably when we are talking about this entire exercise, this is working because of only that IT. So Prabal, when I say IT means I am requesting my container that I want to interact with you. So how do I interact? I can interact it at the time of running the container by getting the command prompt and executing the commands. Or when I say exit and it goes into exit state, I can start the container and I can use attach command, and then I can get the command prompt, and then I can also interact with it. It's just working because of that IT command. Okay, Prabal? Praveen, when we start executing too much commands inside the container bash, it won't occupy all the area of container white table. No, it won't. It will automatically grow itself. Remember, by default, your container will use 1 GB of memory. That is by default the configuration given by your by your Docker. Don't worry, I'll talk about the configuration and little bit advanced topics next week. But today, just remember, it's going to execute one CPU. I mean, it's going to execute with one CPU and 1 GB of memory. Can we change that? Yes, we can, and we have to. How? I'll show that next week. Tushar, it means just once after we use minus IT for a specific container, we can always stop it in exited, not or stop it, start it after exited setters. Absolutely, Tushar. What you said here is absolutely right. Only just correct that stop to start. That's it. And again, it will work as per what you are saying there, right? Absolutely right. So it just because of that IT. IT means interactive teletype. That's right. Your understanding is absolutely right. So what am I doing here now? Probably I want to attach that container. Now see the problem of attach. I mean, things are working. Not it's not like they are giving me a wrong output or whether they are not working, but there's a small problem with the attach. I'm going to go for attaching the container again. See, you cannot attach to a container unless it is running. So I think first let me see whether it is exited. Yes, it is exited. We'll have to start that container and then we'll attach to that container. Okay. Watch what happens. I'm going to clear the screen and open one more shell along with it. You can also open another shell. I mean, open the another command prompt, either put it side by side, or maybe you can put that next to each other, whatever, it's up to you. I'm going to execute the same command here. The container is already connected, but I'm going to start using the attach command one more time. So there are two shells for me where I'm going to attach the container, attach to the same container. See the problem. Container attach Ubuntu. Okay, and again I got the container attached. Now what has happened here, if I show you the picture or the clear picture here, this is my first command prompt, or you can say this is my first shell I've connected to. I opened one more shell and right here I said attach. So this is the problem of attach. We'll see that in a second. Attach. I say attach. If you want, you can open one more command prompt and you can attach to the same bash by using the attach command. Okay, I'll show you how to do that. One sec. I'm going to open one more container just to show you some problem. I'm going to say again, Docker, I'm sorry, Docker container attach to Ubuntu. I have three shells running one after another, right? I mean, we're running, you can say one next to other, and all of them are connected to the same bash shell. Watch what happens. Now, when I start running a command, watch what happens in all of these shells. I'm going to say ls Do you see something? As I type the command, it automatically type it here and here as well. So when I say ls, you see the ls gets automatically typed here and here, and it is showing me the same output. If I say date, see, it is automatically saying the date here and here as well. Again, say date, it shows the same output. If I say ls minus la, it shows exactly same output. What's the problem here? I mean, I don't understand what is going on. Now let me tell you, when you say attach, understand this. This is one of the exam questions I faced. What is the difference between attach and the one which we are going to see in a moment, exec? So see, attach will always attach to the only process it is running, and because there is only one process running, attach will give you the process with one input and one output. Okay, maybe I can do it here. Should I? Okay, now that's the reason I need you to understand the Linux background. I mean, you should have a Linux background first. But anyways, I hope you know that when you are using Linux or when you are using any operating system, I mean, not doesn't matter whether it's a Linux or not, but when you are using any operating system, every process has got three file descriptor. These are called as FDs. One, two, and three. There is one something called as input. There is one something called as the output, and the third one is something called as an error. By default, by default, input is nothing but we call it as standard input, or it's also called as a standard in or stdin. Output, we called it as a standard out or std out, and error we call it as the standard error or std error. By default, standard input or stdin is connected to keyboard. Sorry, connected to keyboard. By default, standard output is connected to monitor, or you can say display better. And standard error is also connected to a monitor or something called as a display. So what happens here is, by default, when you say attach command will give you the same input standard in and same standard out. Attach command is going to give you the same input and same output. Attach command is going to give you the same input and same output. What do you mean by that? This means by default, this bash command is going to receive an input from only one keyboard, and that is going to get sent to all of these commands here, because there is only one stdin, one std out, and one std air that will be shared amongst all of those command prompts or all of those maybe you can say processes here. So this is my first instance, second instance, and the third instance. All of them will share stdin, std out, and std error. And that's the reason why when I type something on one, because it's the same keyboard, it is attached to everywhere, it is going to copy that command. It's going to show me whatever is happening 3 times. If I say exit, watch what happens. If I say exit means all of those commands will come outside, and this command is already given to that bash. The main process is exiting, and that's the reason why it is again making that container to go and exit itself. Do you understand, guys? This requires you to understand this problem or this point. This point is input and output, where we are going to see every command or every process is going to have these 3 file descriptors. May I know how many of you are coming from that RHCSA batch? The one which we have earlier. Akash, you. Anyone other than you? No one? Okay. Now, why am I asking? Because in RHCS, if you can recall, we talked about this at length, and probably, if I'm not mistaken, I don't want to, but it's okay. This is workshop. Do I have it here on this machine? I should have workshops and RHCSA. And if I'm looking at the day one, I hope these are all the slides which I shared. I'm not going to share any one of this to every one of you, so don't even ask me to share that. I'm just telling you one thing because I already have that. I already have it somewhere. Where? Here it is. So this is how we can say that every process has got two things and three things. One is called as std in, second one is called as std out, and third one is called as std air. This is what I just talked about. Every process. This is not Docker. This is pure Linux. So any process in the Linux is not only a process in the Linux, in everywhere. I mean, in Mac also and in Windows also. Every process is going to have one input that's called as std in and two outputs. One is called as std out, standard output, and std error, standard error. And this is the by default configuration for it. Keyboard is the one which is by default considered as std in. Terminal means your display or monitor is nothing but std out and std error. std out is where you can see the output, and std error where you can see the error. By default, it is a terminal where you see both, the output as well as the error. Okay. Anyways, this is something called as a kind as file descriptors, and these are the three standard file descriptors: std in, std out, and std error 0, 1, and 2. Anyways, so I just wanted to convey the message that this is the one that you are you're supposed to know. Anyways, so I'm going to go exit from here, I'm going to exit from here, and now you know what is the problem with attach. So if I go back and again say ls, you see it got exited, and that's the reason why we should not use attach command. The attach command is there, but it is going to, it's going to give you only one single file descriptor. It's going to give you only one std in, std out, and std error. So all the commands, all the processes connected to that bash will receive the same commands at the same time. Tushar, just confirming, all the attaches will be connected to the same process. Absolutely, all attaches to the same process. That's it. I mean, all these processes will attach to the same process. Absolutely right. So if it is not the case, or if it is not the right way to do it, then what is the right way? The right way is to go for another command called as exec. So what is an exec? Exec stands for execute. Watch this, what it is going to do. I'm going to say docker container start. First, let's start this. Start that container with the name Ubuntu. Now, what is going to happen? Again, coming back to this bash will start. Okay. I have to. This workflow is a little bit different. So let me go back and create one more page very quickly. And I will say that this is my machine. Inside my machine, I have got the command prompt here. This is my command prompt. This is my sh or shell. This is the command. This is the container. Right inside this container, we started running that bash. This is what I said last time, bin bash. And now I already have started this. I mean, run -it. We already have started that. Okay. So let us see what happens now. The exec command is going to execute a command inside the container. It's not like attach. It's like just going to execute the command. So the command is like this: docker container exec. Exec stands for execute. What is the name of your container? Ubuntu. Which command you want to execute? Date. That's it. It executes the command and it does nothing. Again, this date command, when I say date command, it is going to give me the date output, and whatever is the output, it will display it here. If I pass ls, same thing what we have done earlier in case of run. So if I say ls -l, it shows me all the contents of that directory, all the contents of that container, and it shows me that yes, my directory and my directory is still there. I mean, I'm using the same container till now. That's the reason I can see the directory 1 and directory 2 created, which we have created earlier, they are still there. I can execute any damn command here. So I can say mkdir my directory 3, and it will create a new directory with the name my directory. And I can see that right there. You see, my directory 3 got created. So I'm using that execute command and exec command. Exec means execute command. And this exec command is going to, execute this command inside the container by passing it to the bash here. So whatever command I'm passing, let's say date, the bash will execute the date and will return the output, and that output we can do it here. Now watch what happens. I want to take the control in my hands. I want to use that command prompt, what and how we can do it. To do this, I'm going to execute the command, the bash. Bash means it is going to start one more container out of it. Before I show this, I'm going to come back to my Mac shell here. And if I say exit, this entire command prompt will exit, because that is the command prompt which is running here. So Don't need that right now. So this is where I'm running the server there. So I'm going to create a new instance here. And when I say exit again, this command prompt will exit, So this command prompt will exit. But if I don't want that command prompt to exit, I can start a shell within a shell. I can say bash, and this bash will start a new command prompt. You see, this was my older command prompt. This is a new command prompt. And when I say exit, it is not exiting my terminal. It is exiting only the bash which I started inside it. So when I say exit, it is executing, I'm sorry, it is exiting the bash. Again, the bash is meant for executing all the commands. And when I say exit, the bash within it, it is going to exit. This is the trick that I want to use here. How do I use the trick here? I'm going to use the command again, saying docker container. Instead of saying exec alone, this time I'm going to say exec, but give me the terminal, give me the control by using -it, and then you can say Ubuntu and say bash. If I say bash alone, it will do nothing. It will just execute and will come out. But if I say, yes, execute that bash and give me the control by using -it, I got the command prompt. Is it like attached? No. What has happened now? Look at this. It has executed a command called as a bash. And because the bash command is going to start a new session, maybe I'm going to do that right here. Maybe it's better we can say in this case, sorry, my bad. I'll just make it a little bit bigger here. So what happens here is it is going to say a bash command, and because that's a bash, it is going to create a new bash command here. So this will spawn a new bash session, and all the commands will start executing right here. So this is the one which I can see right here. And if I say ls, if I say date, if I say time, and so on and so forth, or timectl, which is going to give me all the information about, okay, timectl is not available right in this case because it's a container. So probably there are many other commands you can execute here. But when I say exit, this time, this is the bash which we are not executing. This is the bash, this is the batch which we are exiting, and not this one. In a sense, the exit command will be given to this this bash. In a sense, this bash will exit, this bash will stay there. And if I say exit and say enter, last time when I was using attach command, after exiting, my entire container was getting exited. But this time when I say exit, and if I say docker container ls, you see that my container is still up and running. That is the best thing you can do with the exec. Attach will exit the container when you use the exit command, because it is going to exit the main process. But when we are using a exec command, we are spawning a new process. We are creating a new process for that bash, and whatever commands we are executing, these commands will be executed with the new session. So when we say exit, it is going to exit the newly spawned process or fork the process. And that's the reason, excuse me, the original process will continue to run. Because the original process continues to run, see, the status is up and running from last 5 minutes. That is the difference between attach and exec. Do this and see the difference yourself. I'm going to copy this command right here, so it will be easy for you to copy and paste it and see. Give it a try and tell me whether it works for you or not. By the time, let me see. Can we set path? Yes, Akash, you can. Ankur, have a little confusion for our shell container inside our os commands we are running in the container inside the shell. Yes, exactly, that's right. But we are executing the commands inside the container by using our bash shell or our shell there. This shell is getting attached to the shell inside your container. Are we forking a new process? Exactly, Sachin. We are forking a new process by using the command here. Let's say bash. So bash is going to fork a new process or spawn a new process of bash, and that bash will exit, not the original one. The original one is still working, and because it is still working, probably your container is also working. Your container is also running. If you can recall the attach will exit the container as soon as you exit there. And that's the reason why most of the times we don't use attach, we use rather exec. Exec is the one with which we can go inside the container and execute whatever command we want to execute there. Okay, Minal, can we use a Docker container exec minus it bin bash? Yes, no problem. Bash is bash is the command which is there inside the bin, and bin is already in the path. That's the reason why you can do it. See, if I say echo dollar path, it knows slash bin is already there inside the path. So you can say bash, or you can say bash, or you can say slash bin slash bash. It's like one and the same thing, because it can understand this bash is there inside the bin and bin is there in the path. It can also understand that command, and that's the reason it works. Okay, so yes, Minal, it can be done. Akash, container assign default shell. Yes, it's not the container is assigning, it's like container is getting that shell from the image. You know what? If you look at this one here, the container is getting this bin bash from that image. So the image creator has decided to run the bash command at the end. And that's the reason your container is executing that bash command at the end. Okay. Tanvi, forking happens only in the detached mode. Exactly. This is called as a detached mode. Detached mode, in a sense, we are not attaching to the container. We are not attaching to the main process. We are detached from the main process. And that's the reason it is called as a detached mode. Detached means we are not touching or we are not attaching to the main process. This is the main process. We are not attaching to this. We are creating or we are forking or we are spawning a new process which we are managing here. This is also called as detached mode or detaching with the main process. So this is called as detach mode. This is called as attach mode. So you can interact with the container by using two modes, detached mode and attached mode. We generally prefer using detached mode so that we don't exit from the container as soon as we exit from that shell there. Okay. So this is the difference between this. Shailendra, Docker container exec minus IT bash pwd. Absolutely, this works. Yep, it works. Aniket, it could fork only because you ran the bash command. Exactly. If you run the date command, it will be executed in the same bash. No, in that case, yes, it's going to execute in the same command. See, actually, what is the forking or what is the spawning? When we are saying date, if you know the basics in any operating system, you know that whenever you are using this command, for example, if you say date, the date command is going to spawn a new process. Do you know what? If I go inside the bash and if I say which date, so probably you will say that date is the program, this is an executable of that program. So if I just say file dash, it says file command is not there. Fine, leave it. So date command, the one which we are using, is an executable file, which you can find inside the /usr/bin and /it. This is the executable file. When I say date, it is going to execute that program and then it is going to give me the output there, So when we use this command, probably it is going to give me the output by executing it. How does it do that? It does that by spawning the new process for that date. Every time you pass a command, it spawns a process and then it executes it and it gives you the output of this. When I say bash, a new session or the new bash will be spawned. That's it. This is also getting spawned behind the scene, but we don't say that it is spawning that process. We say that it is executing the command because that's a simple command like date. When I say bash, bash is going to get spawned as well, but bash is made for getting the input from user, and that's the reason you will get the command prompt for bash. Okay. Aniket, I think you must have got it here. Girish, can we spawn new process inside the attached? No, you can't, because if you do it, even if you do it, ultimately when you say exit, your container is going to get exited. Try yourself. If I use the attach command with that Ubuntu, I can say bash, no big deal. I'm going to say exit, the spawn the bash command will get exited. But you know what? When I say exit, and if I say what is the current status of my container, so probably you will see that the container got exited because the final exit is like you are exiting the main process. That's the reason. Okay. Which part you did not understand, Aditya? How it is detaching? It is detaching because when you say something like an exec is going to execute the bash and then it is going to execute the new process. This process is where everything is getting spawned off. You see it here itself. Even if I say attach, you see, I'll have to first start that Ubuntu. And then if I say attach, in that attach case, I can execute all the commands, fine. If I say bash, this command prompt is the one. If I say ps, I think ps will help you to understand this is the main process and this is the newly added process, so we are inside that process. If I say exit, which process is getting executed, sorry, which process is getting exited, the other process, sorry, we'll say exit and we'll say ps first. Leave it. When I say ps, you see that this process we created last time got exited. You still have the bash command here, but now when I say exit, the main bash will exit, and that's the reason why it is generally called as a detached mode. So Aditya, when we are saying bash, it is going to spawn a new process. You see that with the ps, and this is how it is going to do it. It's amazing. I know that it's really amazing. That's the reason why I fell in love with this. Not only Docker, Kubernetes is even more interesting. Jenkins is even more interesting. OpenShift and stuff like that. They are mind blowing, mind blowing. That's the reason I'm in love with this DevOps. This is really amazing, guys. I mean, hats off and salute to those people who have invented and who have written those tools. See how many, how talented these people are. They must have thought of all of these things. Really great. Anyways, coming back here, I think you now must have got the difference between the exec and attach. So attach is going to attach to the main process. This is the detached mode. So it is going to get attached to the main process. And that's the reason when you say exit, it is going to exit the container. Detached mode, it's going to start a new process. So when you say exit, it's not going to touch the existing process. That's the reason why it is going to exit only the bash, not the container. Container will stay there. Okay. The running shows only one bash. Exactly. Sachin, exactly. It will show you only one bash because, see, I'll show you the problem, not problem, but I'll show you how does it work. When I say container exec, and you don't have to say -id, you can say Ubuntu. And if I say ps, it shows rather it shows nothing right now because the bash is already running, and this is starting a new execute command. This is starting a new process. That's the reason why it doesn't show you anything. But when you say bash here, it is going to spawn that bash, and that bash will get will get exited. There is no command. It is waiting for accepting from the user, so it will exit. That's the reason why it doesn't show you there. So there is nothing wrong here, Sachin. It shows only one bash because this bash is exited. That's the reason why you do not see that there. You go inside it and then try that. It will show you, if I say IT, this is the main bash. If you say ps, it is going to show you this bash, the one which you spawned here. But it is there because you are inside it. You span one more bash and you see ps, you see two bashes. You see exit, you are exiting from one bash. You say exit, you are going to spawn one more bash. That's how it is going to do the job. Okay, so it is going to spawn a new process every time it is going to do the job. If a container is already running and we run it again, will it start the another container? Of course, it will start the new container. No container will be started again. So container, when you say run, will start a new container. Okay. What happens to the parent bash? Nothing. Parent bash will stay as it is. That's the main reason why we are using the exec command instead of using attach command. Sachin. Kavish, Docker container exit IT minus Ubuntu bash. After using this command and exit command coming out of it should remain. It should remain inside the bash. No, it will run behind the scene, but you will come out of it. So you will see your operating system's command prompt. But if you say Docker container ls-l or ls-la, whatever, you see that it is up and running. It will not exit because we are using the exec command. Okay, the parent bash will not exit. Sachin, the parent bash will not exit. Right? Parent bash will not exit if you're using exec, and if you're saying attach, the parent bash will exit. That's the main reason we do not use attach, we use exec instead all the time. So whenever you want to execute something, you always will go for using that exec command. Okay. Yes, can we modify the files in the container with the proper environment consistency? Yeah, of course you can. You can modify the files inside it. But see the problem now. Do you remember in my container, if I say if I say container exec, Ubuntu. I don't have to go inside it. I can say ls minus l. Watch what happens. When I say ls, I am supposed to see those three directories, and yes, it shows me that yeah, I have created three directories here, 1, 2, and 3. Those three directories are still there. I'm going to exit that container or stop that container or remove that container. So I'm going to say docker container. I want to remove that container. So I'm going to say rm ubuntu. RM Ubuntu, it's not going to allow me to delete it because my container is still started. I mean, it's still running. No big deal. We can use the command with -4 parameter. The -4 means it will first stop it and then it will remove the container. So if I say container ls minus a, you see that the container which was running earlier is gone now. It's gone in a sense, the container is deleted. But when I say docker container run, okay, see docker container run, again if you want to say -it, that's fine. You can say something like ubuntu, or maybe I can say minus name ubuntu. So I'm going to do the exact same configuration which I did last time, ubuntu, exactly same. And if I say ls or ls minus l, you see that those directories are missing here. Those directories are missing because the container which was having those directories, we deleted that, and that's the reason why we call it as immutable. Someone was looking for that answer, like why it is immutable, though we can modify the contents of it. It is immutable because it's not persisting its state. Once the container is gone, you will lose all the changes you have done inside it. That's the reason why it is called as immutable. By the way, who was that? Who was asking that question last time? I forgot name. Someone asking that question. So Robin, do you understand it now? So probably this is the reason why it is called as immutable. If you delete that container, you will lose whatever is there inside that container. So that's how it is called as immutable. You cannot save the contents of that container. That's the main reason why you are supposed to use volumes and storages later in order to process the data outside the container. We'll see that in a moment. Okay. Sachin, you don't, what have you not understood? I assume the Docker container exec Ubuntu bash will create two bash. One is the default parent and the bash will image. Which one is executed from exec put? But PS shows it only once. Yes, PS will not show the parent one when you are in the exec mode. So probably Sachin, you are getting the right things. In the exec mode, you will not see the parent process. It will show you only when you are in attach mode. That's kind of, how it works. So when you're in attached mode, you will see the parent. When you are in detached, you won't see that. Okay. Harshal, your question. It's quite logical. Deleting a container deletes the stuff inside it. Exactly. That's the reason why it is called as a immutable object. Or you should not trust that container to save its save its state even after it exits. So don't save anything inside the container. That's the reason why containers are called as immutable. Okay, what is that? Prabal, Ubuntu. Is it a compound command? You can say so. Harshal, can we make a copy of this container and save it later use? Yes, we are going to do that in a moment. So wait and hold for it. Sachin, so kind of connecting the file descriptor to the new bash, but not the parent bash. Absolutely right. You are connecting the second one, or you are creating a separate session and then you are creating a process there, and then you are using the FD there. I mean, SCDIN, SCD out, and SCDR. You are attaching it to the separate one. That's the reason why it is going to be literally separate. So we can store it inside the volume. Yes, we can. We will see that later. It makes the isolated behavior. Absolutely right. So I'm going to show you the same command one more time or the last time. See this attach command I showed you earlier. I'm going to go back here. Let's see the container, whether it is running. Container ls minus a. So this is the container which got exited because I went from the, I came from the IT. Not a big deal. I'm going to start that container again. Start Ubuntu. Watch what happens here. I'm going to put two command prompts side by side. Okay. And we are going to run the same command in both the cases. So it's going to be docker, not the attach command, the exec command, or in the detached mode. So docker exec, docker container exec. I want to say -it and Ubuntu bash. Okay, this is where we are going to say docker container start, not start, container exec minus it ubuntu bash. Okay, so when I say ls, it works separately. When I say ls, it works separately. So if I say date, I see the date is getting separately executed. I see that maybe I see ls minus l getting executed here. So both of them are not kind of attached to each other. When I say ps here, when I say ps here, you see that the bash here is having a separate id and the bash here is having a separate id. Sachin, see, it is not showing you the parent bash. Why it is not showing you the parent bash? Because you are in detached mode. In the attached mode, if you look at the bash's PID, it has to be one. It has to be one, So let's do it quickly along with this. See this. I'm going to say Docker container attached to that Ubuntu, and watch what happens. I'm going to attach to the main process. So if I say PS, it has to be one. It has to be one, So this bash is one. This is the main process. This bash is 18. This bash is 9. Separate processes. Watch what happens now. If I say exit, I'm exiting from the main bash. When I say exit from main bash, you see I got thrown out from both the containers because this container is exited, So even though I was inside this container from two different terminals, I completely thrown out of those two containers because the container is already gone, This is the way you should do it. Mayur, both the processors are sharing the same working area. Yes, they are, but ultimately they are spawning the two new processes. Remember, namespaces and C groups. Magic behind this. Searching parent is like the init method here. Yes, that is the main job of container. I don't know whether you know this part or not, but Sachin, you literally, you literally have kind of said the right thing here. What happens here is, guys, listen to this carefully. Even if you don't know that, if you know it, well and good, it's a eureka moment for you. But if it is not, then just ignore it. What I just said. Yes, Sachin, that's a eureka moment. When you run or when you boot your operating system, there is a sequence. It goes to the post, means it goes to the power on self test, then it starts, it goes to the BIOS, it looks for the the entry point, and then it goes to that hard drive where it is stored the booting code, and they execute the boot code. It loads the kernel, and kernel starts the init process. The init process starts your shell, and it will show you the login prompt. You know what container does? Container replaces that init command with the bash. So as soon as the container starts, it does nothing but it executes the bash. So Sachin, you said that absolutely right. It replaces the init command with the last command inside that Docker file. So Docker file's last command is nothing but your init process, and that is the only one it is going to execute when container starts its life cycle. Yes, that's how it does the job. Exactly right. Tushar, making directories in one will reflect in another. Of course, directories will get reflected because directories are going to get created inside the container. So yes, they will persist. They will stay there till the container is there. Siley, both of them are creating the separate bash from each other within the process. Yes, these are the separate processes, and they are creating separate processes for each other. I mean, they are not having anything in common. They are kind of doing this different job at the same time. Is it scaling like increasing the processes? No, that is not scaling. Scaling is different. We'll talk about that later. So right now, hopefully after doing this exercise, one thing is very clear, that when you are creating a container, when we are creating a container, there are two ways I can attach to that container. I can execute the job inside the container. One is attached mode, and the second one is the detached mode. Okay. Now, one thing I don't know whether you have noticed or not. Let me delete that container again. Container rm Ubuntu. It already got exited, so I don't have to stop it, or I don't have to use --4 step. So when you say container create, what the hell? Here it is. Container. Sorry, it's already there, I guess. Exec minus it. Now what happens here is, when you say exec minus it, I think Ubuntu is the name. Okay, Ubuntu. Maybe, I'm sorry, minus name Ubuntu. It will be easy for me to remember that. and Ubuntu is the ID. So when I say that, it goes to it goes to the command prompt, and when you say command prompt, you come out of the command prompt, it will automatically, I'm sorry, not exec command I'm talking about, run command I'm talking about. So what happens here is, by default, it goes to the attached mode. See what happens here. When I say run, it creates a new container, it goes there, and then if I say exit, you see that the Docker container status is by default exited. When I say exited, that simply means this by default goes in the attached mode. Now you understand what I mean by attached mode. So when I say exit, if the container is getting exited, that means it by default goes in the attached mode. What happens here is, if I want to start that container, and if I want to run that container continuously behind a scene, but still want to have that IT interactive teletype parameters. See, I'm going to show you an option here. Instead of running this container with only -it, you can add one more parameter called as a D for detached. See what happens now. When I say D, it will not give me the container, I'm sorry, it will not give me the command prompt directly. But when I say D, it will run in the detached mode. When I say detached mode, you see that container ls -a, you see that it is up and running. Last time when I was just saying IT and I was exiting, it was exiting from the container because it was running in attached mode. And D here will run it in the detached mode. That's the benefit of using D parameter at the time of running this container. You see, I got one more option here for you guys. So either you can run this in this way, or you can run that by using -itd. It's not minus minus, it's only minus. A parameter sequence doesn't matter. You may pass this parameter first and this parameter later. So D here at the time of running the container will create a container D for detached mode. And when you say detached mode, even if you say exit, it is now going to get exited. So I'm going to use that same command exec one more time just to confirm all the things again. Exec Ubuntu, I'm sorry, exec -it. Here we don't say D, here we say exec it Ubuntu and say bash. I'm going inside this. I can do whatever job I'm supposed to do. I'm going to say mkdir dir 1 dir 2, or maybe I can say dir 1, let's say 2 to 10, or 2 to, let's say 100. I'm going to create 100 directories. I'm sorry, I want to create 100 directories. So if I say run, I got 100 directories there. So now I'm going to say exit, and if you see that ls -a, you see that it is still up and running. When I say force delete this, rm ubuntu --force, it will delete that container. And if the container gets deleted, and if I start a new container, you know that because it is a new container, you see, you cannot expect all those directories which I created earlier. As simple as that. So guys, now you know how to start a container in attached mode and detached mode. What's the difference between that? How to execute a command inside the container, and how to get some things done with your container. So this is something that I wanted you to first understand. Okay. May I get a confirmation, guys? Have you understood all of these things, what we have done here? Very good. Now watch this. Right now we were using Ubuntu, or you can go for Alpine as well. That's fine. But this time I'm going to go for one more other container. Let me just go back image and ls. There is one more, something like a Nginx. You can go for Nginx, or you can go for a server. Okay, maybe we'll look at the Nginx a little bit later. Let's use the MySQL first. MySQL is where we are going to create a database. So watch this. I'm going to use that container. So I'm going to start that MySQL image by saying docker container, container run -it, D for detached, --name, MySQL, and MySQL is the image name. So one process will start created. One process, I'm expecting that container will start. Now, when I say container start, seems like the Ubuntu is still running. I don't want to keep that running. So I'm going to say rm --force. The Ubuntu is the container that I want to stop. But did you notice something? It's not showing me the MySQL one. MySQL is not showing up. Why the hell it is not showing MySQL? MySQL gets exited. How do I know why it is getting exited? Let's look at this then. If I want to see why it is exited, or what are the different things it has logged behind the scene, I can say docker container logs, and then the name of that container That's MySQL. It tells me that everything is okay. SQL, I mean the entry point script, blah blah blah. MySQL, it's running, blah blah blah. But you see the error it is giving me. Database is uninitialized and password option is not specified. See the error. It says you need to specify one of the MySQL root password, MySQL allow empty password, and MySQL random root password. Means whenever you are creating a container, there are few parameters that you are supposed to pass, which I go back inside the Docker Hub and search for the MySQL, you will find the information for those parameters here. So if I go back to the MySQL, you see that when you are going to create a container out of it, it is mandatory for me to pass some environment variables. This is what I wanted you to see now. So if it is the environment variable that I need to pass, let's say if you look at the in MySQL, I hope everyone knows what MySQL is. MySQL is a database which requires you to log in with the user like root, and root has to have a password. So I have to pass the environment variables to that container. So the container can create a root with that particular password. So it says this your environment variable is mandatory and it specifies the password that will be set for the MySQL root super user. Okay, so now it's not like only minus itd or minus rm, all of these parameters we need to pass, but there are a few more parameters. Like I want to set environment variables sometime. Now how do I set the environment variables? Watch this. So you saw that error here. This point, this Docker, I mean, this container is of no use because it's already got exited, and I know it's not going to start anytime because we did not provide the password there. So I'm going to delete this one here. You know how to delete that? rm mysql. So the container got deleted. Watch this now. I'm going to create a new container now with that MySQL name, and this time I want to set one environment variable. How do I set an environment variable? Minus E. E stands for environment variable. Which one you want to set? MySQL underscore root underscore password, which is equals to whatever password you want to supply here. You can say root. MySQL root password. It's not like I'm specifying it. It's like the documentation tells me that this is the one that you have to supply. This is mandatory for me. When I supply that, I'm going to copy this command for you. You try that on your machine and you will see that on your machine, you are starting with MySQL inside the container. And guess what? If I say Docker container ls, you will see that MySQL is up and running. How do I go to that MySQL? To go to that MySQL, again, the container is running. I want to go inside it. You know the command now. All we have to say here is Docker container exec. Don't go for attach. Say exec minus it MySQL, and this is running running on top of Linux. So bash should be there. So I got the bash command, and this is my MySQL minus u root minus p. Root is the password. Show databases. You see, show databases, it shows nothing right now. I can create a database, create database MyDB, for example, use MyDB. I can create a table very quickly. Create table, let's say person, ID, integer, let's say primary key, auto underscore, I guess, increment, increment, and increment. Person is going to have a name, varchar 100. That's it, more than sufficient. I got the person table created. I'm going to say insert into person. I'm going to say insert a name, values, let's say person 1, and we'll insert one more record. And if I say select star from person, you see I got my entries in that table. I'm going to get exited. If I go for exit again, if I look at that Docker container ls minus l or ls minus a, it shows me container is still up and running, and this container has got my database, MyDB there. I don't know whether you have installed MySQL on your machine or not, and whether you have faced any issues or not. After this point onwards, you don't have to worry about this. You want to install MySQL? Don't worry, just run one command and you are done with it. You see, Docker container run minus itd minus name MySQL minus u blah blah blah. MySQL is running. You want to run Mongo? Run the similar command. except MySQL, say Mongo, Mongo will run. You want to run Redis, do the same thing, Redis will run. You want to run Postgres, do the same thing, Postgres will run. I mean, if I show you my other desktop, other machine, there I run 6 different databases simultaneously for my other purpose, for my other projects. I don't have to install any one of those on my machine explicitly. That is the beauty of Docker. If you use the Docker in your daily environment, believe me, guys, your machine will have no thing. I mean, no database or no software installed explicitly. You can everything. I mean, you can run everything inside the container, almost everything inside the container, which will make your life so simple, so simple. Yes, Mayur. Now I understand you have run the Mongo image with ITD command. Exactly. That's what you see here up to 15 because yesterday only I configured it, And actually what happens is when I restart my machine, I always stop my Docker and that's the reason it restarts it again. That's it. Exactly. Robin, before that, we need to pull the Docker command corresponding it. Yeah, you don't have to pull the command explicitly. It's fine. I mean, you can say that pull MySQL first, or even if it is not there, you see your desktop, you see your command prompt, it says that the image is not found locally. So it starts pulling it on its own. So explicitly, Robin, you don't have to pull it. If you want, you can, but you say the run command, it looks for that command here on your machine. If it is not there, unable to find locally, it goes to Docker Hub and it downloads it. Can we install Eclipse? You can, but you won't be able to run that because Eclipse is a GUI. You can't run GUI applications in it, Mayur. Okay. And why you want to run Eclipse in the first place? Eclipse is one of the worst editors I've ever seen. I don't want to even use that name, but still, I don't know whether you like it or not. Sorry if I'm hurting your feelings, but I. It's not like me. There are many developers in the world. They really hate that application, but still, sorry for that. Coming back to the world again. See, this is what I'm telling you. If you start using the Docker on your daily usage, it will make your life so simple, guys. So simple. Anyways, I can't tell you how happy I was a couple of years before, explicitly in 2015 when I saw this running on my machine for the first time. I felt so relieved that I didn't need to. I mean, after that, I never have installed databases on my machine explicitly. I don't know whether you have done this or not, but installing all those databases, multiple databases on machine is really painful. I can't use other words, but it's really painful. Docker has made my life so simple, run whatever you want to run in separate containers. There'll be no conflict. Sometimes one file in the database or one library in the database causing another issues in another databases. I've seen those issues earlier as well, but now there is no problem. Tushar, we should be able to run our REST APIs, and of course, yes, that's what we are going to do right after we are done with this. Of course, yes, we are going to do that. I'm going to show you an example of it as well. Harshad, maybe this question is not the right time, but is it possible that amount of memory required for these containers to go overboard? No, they will never go to. I mean, they are not going to exceed the limit because of the C groups. You can configure them. I'll show you how to do that by using the resource limit command. We'll talk about that later in the next week because there I'll show you how to make the local and global configurations. Okay. Or like too much processing is caused to the cache. No, it won't. I mean, does the developer has to worry about the amount of memory being consumed here? Yes, we have to. And this can be configured locally or globally. How? I'll show you that in the next week. Next week is dedicated for configuration, security, and the last point will be EE. That's what we are going to see. And of course, the networking advanced part. Okay, so Harshad, you are going to get that answer later in the next week. Rishabh, like MySQL, can we run the Oracle client? Of course, go for this. You know what? Just search whatever you are looking for. You want to look for Oracle? No big deal. Oracle is already having it. Of course, the license is something that you have to bring on your own. But you see, the Oracle instant client, it's already there. Oracle Linux, it's already there. So yes, you are having every single thing, Rishabh. Whatever you are looking for, search here. If you find it, you don't have to install anything on your machine. Literally, you can run everything inside the container. Anyways, I think that is it. I mean, this is how we can use the different images. We can play with them. We can use something like -e to set the environment variables and stuff like that. Okay. Now, again, one more interesting point. And believe me, when you see this, at least those people who are developing websites, they will be really, really happy to see what I'm going to show you now. But for that, you will have to wait for some time, because we are going to take a break in between. So I'm going to hold your excitement. Probably we'll take a break first. We'll come back and I'll show you what I wanted to show you here, and what I said here. You will feel very happy when you see that functionality. Okay, 15 minutes, not 20 minutes. 20 minutes or 15 minutes? 15 minutes, more than sufficient, right? Yes. How much time you'll need to have a cup of coffee? More than 15 minutes? No, I think that's fine, right? Yes, servers, exactly. Mayur, you got the point. But what is that? We'll see that. 15 minutes timer. And you will see that in a moment. So let's take a break, come back after the break, and we'll see the things, okay? Okay, guys, I think you are there. And if you're there, let's continue further. Okay, so last time we saw a couple of different cases, and hopefully we already have understood like what are the different ways we can start the containers, we can manage the containers. And now I'm going to go to the next point. So I said that those people who are developing websites would be very happier because now I'm going to show you how to run the application, how to host the application or website inside a very simple web server. Okay, see how it can be done. Now, if you are going to execute your website or if you want to host your website, you need something called as a web server. So there are a couple of, I can say the famous web servers out there. Nginx is one of them. So you can use Nginx for sure, or you can go for pretty old HTTPD. That's going to be your Apache. So you can search for HTTPD, and this is nothing but the Apache. Nginx is a little bit more professional, will be kind of better performing than the HTTPD. So generally, when you are in the production, people will prefer using the Nginx. I'm going to show you both the examples, by the way. So now I'm going to run an application here inside, or application here in a sense, I'm going to run a website inside one of the web servers there. So look at the problem and look at the solution. So what we need to do, okay? So I need to use, say Nginx is already there on my machine. So I'm gonna go back here and say container ls, sorry, image ls. And it seems like Nginx is already there on my machine, okay? So I'm gonna use Nginx right now and we'll create a container out of it. I'm gonna say docker, sorry, container run minus itd. Now you know all the meaning of this, right? And then I'm going to say minus minus name. I'm going to put a name there. Let's say nginx, and name of that image is nginx. So it has spawned a container. I'm going to put that right here. This is for web servers, guys. So when we are saying like this is the web server, if I go for the container ls, you will see that the web server has been started and web server is listening on port number 80 because it is using HTTP protocol there. See what has happened and what is the problem and what is the solution. So if you look at the big picture, this is my machine, this is my machine, and inside this machine I have created a container. So say this is the container. The container has started one server within it, which is Apache. In this case it is an Nginx. It can be Apache as well, whatever, it depends on you. This is, let's say, Nginx. Now, if you look at this Nginx, it has started on port number 80. So it is listening on port number 80 for now. And this port number 80 is nothing but it is hosting one of the websites there. So probably inside this, there is a directory called as /usr slash share slash nginx, sorry, slash nginx slash html. This is the directory, and inside this directory there is a file index.html, and this file is hosted on the port number 80 inside this nginx. So this is what it is hosting right now. Maybe this is a container and every container has got an IP address. So probably if I go to the container and if I want to find out the IP address of it, I can say docker container inspect. I guess I mentioned this command yesterday. Inspect, the name is nginx. So inspect command is going to give me every detail about that container, running container. So enter. And just a sec, I'll put this command right there inside. Where is it here? It is. So this is the command. I want to put this right here so you will understand what are the different parameters or what are the different output you will get. You will get ton of this. I'm not interested in that right now. All I'm interested here is in the IP address. So this is an IP address 172.17.0.4. Okay, see the problem here. The problem here is this container has got an IP address. Fine. I mean, I can see that the container has its own IP address, but the problem here is I'm not able to talk to that IP address here. Imagine this is my machine. Let's say, let's make it a little bit smaller. So this is my machine and there is a network here and there is another machine here. There is a client here. and this client wants to see that see that website from that container. The container has got an IP address 172. I saw that there. 172.0. What was that? 172.17. Sorry, not 0. 172.17.0.4. That's an IP address of this container. I saw that there. So this is the IP address on which the container is listening on port number 80. And anyone who is having, who can hit that IP address can see the website which is hosted inside that container. But how do I reach this? Because this is going to be a private IP address, and not only this is the private, it is available only within this machine, and that is the problem. What is my machine's IP address? My machine's IP address is 192.168.1.19, I guess. Just a sec. Let me see here. 1.19, I guess it's a dynamic. So 1.19. So 1.19. So this is the machine. Let's say there is another machine. There is another, let's say, MacBook here. So 192.168, 1.4. This is another machine I'm using. And probably from this machine, I want to view this website. How is it possible for me to connect to that 170.17.0.4? It's not possible. So how do I connect to that running instance? It is running, no doubt. I can see that it is running. I can go back here and I can say that Docker, Docker container, and let's say ls. You see it is running, it's listening on port number 80, but I can't talk to this, I can't use this. What should I do? To do this, I'm going to follow one pattern. This is called as port forwarding. So this is called as port forwarding. So what is a port forwarding? Port forwarding means I'm going to expose a port here, whatever port, it's up to you. Let me expose port number 8080. I can also expose port number 80 if it is available on my machine. But see, I'm going to assign this port number here on my machine. The other side of it is my machine. So this is the yellow color. You see, this is all my machine here. And the one which is there inside that, the yellow box is nothing but the container. This is my machine, guys. The physical machine on which that container is listening right now on port number 80. So the container is running on my machine, which is kind of having the yellow color here. And probably, let's use this one. This is the blue color, which is nothing but the container. So container is running a process, Nginx, which is a web server, and which is listening on port number 80. So what am I saying here is this. I'm going to allocate, or I'm going to expose a port right here on my machine, let's say port number 8080, and I will forward these requests to the port number 80, which is maybe created inside the container. When I say that port number 80 is here, by default, it should be the port number. Maybe I can just remove this part here, and I can say that I know it's an Nginx which is doing the job, but for understanding purpose, I want to say that this port number is kind of given to the container. So this is listening. The port number 80 is kind of given on the container side, something like this. Port number 80 is inside the container. Port number 8080 is outside the container inside my machine. So what am I going to do now? I'm going to get all the requests, incoming requests on port number 8080, and will forward all of them on port number 80, and get the response from port number 80, and will get them on the port number 8080. So whoever wants to talk to that container, instead of talking to that IP address 172.17.0.4, will literally send a request on my machine 192.168.1.19 colon port number 8080. And when I say 8080, the request will be listened on this particular interface, on this particular port, will be forwarded that request to the container. Container will go inside the Nginx. Nginx will read the file right here, and then will send the response and will send it to whoever has sent the request. So this is something called as a port forwarding. How do I make that working? No problem, I'll show you right here. See this. I want to stop this container, because unless you stop that container, you cannot modify this, or you cannot start the new container with the same name. So let us delete this first. rm --force nginx. I'm going to delete that container. This time, when I start the container, I'm going to forward the port. Port forward can be done by using minus P, P for port. How do I do that? Source port is port number 8080 on my machine. So port number 8080 on my machine, colon, the destination port is a container port number 80. So this is the port number 80. Port number 80 is fixed because of Nginx. Port number 8080 is configurable. You can use any port number there, doesn't matter. I'm using 8080 because I know 8080 is free on my machine. When I say enter, it is going to start the container, but this time, this container will receive all the requests on port number 8080 on my machine, and will forward this request to port number 80. See, it is going to listen on my machine. 0.0.0.0 is nothing but my machine on port number 8080, and will forward these requests to port number 80, which is nothing but the containers port on which Nginx is running. How do I see whether it is working? Not a big deal. Come back here and say localhost or your machine IP address, doesn't matter, colon 8080, and boom, see, it shows welcome to Nginx. Excuse me. It is showing welcome to Nginx means I hit that URL. Localhost means the same machine, colon port number 8080, and that 8080 has sent the request to the Nginx containers port number 80. Has this has been received by Nginx. Nginx went to that folder, read that file, and then it has given you the output, and boom, I see that welcome to Nginx here. Can you give me the confirmation that it is working for you as well? We did not start Nginx. Of course we started. Didn't I give you the command? The command is already there. Look at the last command here. Docker container run -itd -name nginx -p 8080 colon 80 nginx. That's the command which is going to start the container on port number 80. And 8080 is nothing but my machine's port number. I'm forwarding the request from 8080 to port number 80. That's how it is doing the job. How did it send the request to Nginx? It's just because I'm saying localhost means the my machine. I can use my IP address as well. 192.168.1.19 colon 8080. That's one at the same thing. Localhost 127.0.0.1 or maybe 192.168.1.19. It's going to show you the same result. I missed one point, that how do we know the port number 80 is assigned to the container? Absolutely, and that's the right question. How do I know the port number 80 is assigned to the port inside that Nginx? I know that because if I look at the Nginx documentation, and this is where the documentation is needed. So if I look at the Nginx here, Nginx mentions like which port number it is using. So probably if I just go back here and if I look at the port number, the documentation will tell you that there is a port number. You see, this is where the example is already given. The port number 8080 also, they are also using 8080, and 80 is the one which is kind of configured inside this one. And if you really want to see this, you can click on any of those Docker files, and the Docker file will tell you by using an expose command right here. The expose means this is exposing port number 80, and because it is exposing port number 80, Suman, this is how I know that I'll have to send a request to port number 80 there. Okay. Yes, how is it forwarding it? It is forwarding because I have allocated port number 8080 on my machine. It is going to receive all the requests on that port number 8080 and then forward it on port number 80. So when I say this is the URL, I'm sending a request to my machine on port number 8080. See this, port number 8080. This is the port number 8080 sent. Request has been sent on my machine on port number. This port number has sent the request to the machine, port number 80. And that's how we are getting the website running inside the container. You see, Madhukar, -p builds a routing table and sends a request to Nginx. Yes, next weekend we'll talk about advanced networking, and there we'll see how the DNS is configured by default by Docker, which is running on 170.17.0.11. We'll see that. 0.1. We'll see that. So DNS is something which is configured by Docker behind the scene. The routing table is configured by your Docker behind the scene. We'll see that. Right now, don't worry about the routing table and other stuff. Look at the way we are getting the request maybe handled by the Nginx and see the output here. Okay. I think Robin, you are now getting it right. Harshad, can you please explain the internal implementation. Next weekend I'll explain it. What's happening in the background, some routing table. Yes, routing table will be created and will be configured behind the scene. How? I'll show you that later. So right now it seems like the things are really working, but this is the welcome to Nginx command. Where can I put my code? Where can I see my changes, or where can I see my HTML? Oh, that's not a big deal. To do this, we have to go inside the container. Now, can you tell me the command to go inside the container so that I can modify a few files and see how we can get the my contents instead of saying the default engine, default index or HTML? Yes, minus itd is okay, but what is the command to go and execute that bash? Exec, absolutely. So now you see, you got the point there. Docker, you can say container exec command minus itd, not d, only it, because I want to get the control back from the nginx, and the command is bash. You can go to that directory. Which directory? /usr, the one which I mentioned there, /usr/share/nginx/html, and there you will see a file index.html. If I see contents of it, cat index.html, this is where it shows. You see, welcome to nginx. If you see this page running blah 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 blah, you see that exactly what it show you here. Welcome to nginx blah blah blah. So this file is getting hosted inside the container, and this is where we are getting it here. What if I want to change the contents of it? No problem. You can say Vim is not installed, I guess. Let's try it. Vim index.html. It's not available. If you want, you can install it. This is going to be apt-get install Vim. Unable. Oh, sorry. Update. First, you will have to say apt-get update. This is running Ubuntu, and I can install Vim now. See, Vim will be installed. And because Vim is installed, probably I'm going to go back and input this nginx, this index.html, and I can modify it as per my requirement. If you know Vim, you can easily do it. If not, you will have to use something else. So probably I'm going to say h1, maybe, h1, and say welcome to my website. You can copy your website details later by using a custom image, but for now I'm going to do it in this way and say refresh, and boom, you see welcome to my website. As simple as that. Yes, we will see that in a moment, how to do it separately. If you don't want to use Vim, or if you're not comfortable with Vim, use this command echo. You can say h1, you can say welcome again to my website, /h1 to something like index.html, and make sure that you are inside the correct directory. I'm going to copy this here, and we'll put it there. So for web hosting, maybe we can go back here and say this is going to be HTML, for example. Oh, this is the bash command again. So say bash command and execute this command here. Okay. So I'm going to put that right here. You just go back and say you are executing this command there on the right directory. Wait a second. The directory here is, first you'll have to change that cd/usr/share/nginx/html, and then execute this command echo blah blah blah. It is going to do the job. And probably if you say refresh, you will see what exactly you are supposed to see. Welcome to my website. That's it. So this is how we are going to do the job. What's the command to install Vim editor? If you want, you can do it in this way as well, or you can go for maybe or is the comment here, sorry, and then you can say, so you are running with the root privileges. So apt-get update, and again apt-get install Vim, and then you can do the same job. Vim /usr/share/nginx/html/index.html. So do it in this way. Okay, copy and paste it, you will be done. Okay, so probably this is how we are doing it. So now whatever is there, you will see it here. If I just want to change that one more time, instead of saying welcome maybe this is my first website and blah blah blah. I'll say that, or maybe I can open that vim command, and then this is what I did last time. I'm going to literally copy this. Sorry, maybe I'm just going to copy this here and paste it couple of times just to see if it is working or not. W, and if I say refresh, you will see all of them right there. As simple as that. Nginx pre-configured and it was ready to use in a Docker provided it. No, Nginx has been created by the Nginx community. This Docker image is provided by the community, and it's already been pre-configured to run that welcome page, the one which I showed you there. Okay, can I put my index file there? Of course, that's what we are going to do by creating our own image in a moment. So do this exercise very quickly and tell me if you are able to see exactly what I showed you there. Working, very good. Yes, this is what I'm expecting you to do it, and hopefully if it is working for you, that means you must be getting it, like how to run websites inside the container. Prabal, generally with a server we need to explicitly start the server, but we don't have to do it here, because by default, again, this Nginx is going to do only one thing, Nginx -g daemon off. It's going to start the Nginx in the foreground, so we don't have to do anything like that. So container will automatically run that Nginx. Container is meant to run only Nginx. That's it. Prabal. So we don't have to. Good. Praveen, why this Nginx container not exiting when we run the container run? No, you didn't see that, I guess. I used a -itdd, which is making the little bit difference here. D is for detached. It is running in the detached mode. That's the reason. Okay, Praveen? It's -itd. D is for detached. That's the reason why it is running continuously behind the scene. Yes, and when I say exec, it already has created a separate process, separate bash process for it. That's the reason. Okay. Anyway, so I hope you all are getting the output, and probably now you must be pretty much excited to create your own image, so that instead of getting this index.html, I will get, or I should get, my own image. Okay, let's see how we should do the job. By the way, if you don't want to use Nginx, there is another one which I showed you. This is HTTPD. The only thing which will change is the path. The rest of things will remain same. You see, you can also go for HTTPD, and you can use this one here as well. So I'm going to start this one here very quickly. Let's say this is docker run -itd. -itd, let's say minus name. I'm going to use Apache, whatever you can say, -itd, minus p. 88 is used by my Nginx, so I'm going to say 8081, for example. Doesn't matter, you decide which one you want to go for. Second is important, 80, because HTTPD is nothing but Apache, and Apache also runs on port number 80. So behind the scene, it is going to work on 80. I'm going to create 8081, and then I'll forward it to the Apache there. Okay, and this is HTTPD. HTTPD is not there on my machine. You see, unable to find the image locally. It's going to go back to the Docker hub. It's going to download this. See, and probably it has already started it now. So probably if I go back and try to see Docker container ls, you see both of them are running internally on 8080, but one is using port number 8080, the other one is using port number 8081. So if I go back here and if I say localhost port number 8081, it is the Apache. It shows it works. This is Nginx and this is Apache. The same exercise, you want to do it again, you can do it this way. Container exec, what is that? Apache. And you want to run the, I'm sorry, we'll have to use -it for that. -it Apache bash, So probably we are in the same directory /usr/local. The path is a little bit different, /usr/local/Apache. Right inside this, if you go to htdocs, this is the directory, and here you will find the index.html. Again, you can say vim index.html. Index vim is not available, no big deal. I'm going to go back here and say apt-get update. Maybe I can say ampersand apt-get install -y vim. So I don't have to say anything there. It will automatically do every single thing on its own. And the Vim will be installed. Minus Y is for accepting it automatically. Otherwise, it will ask me whether you want to install it or not. So now if I say vim index.html, you see it shows the it works, whatever it is there. I think I can change that to say welcome to my application or blah blah blah. This is my website, for example. And later on you can put your own contents as well. And if I go back and if I say I'm sorry, if I say refresh, sorry, if I say refresh, you see instead of it works, it shows this is my website. Same case, but we are using a different web server. The web server here is Apache. Last time we were using Nginx. That's the only difference. If we have multiple images running on the same Nginx, then we have to give multiple port numbers. Naturally, multiple port numbers for forwarding. Absolutely right. You cannot use the same port multiple times. So you have to think about some other port. Yes, that's the way you should do it. Aniket, these Vim commands are being written to the right layer of the container. Yes. Are those additional layers to the images? Yes, that's the right container, sorry, the right layer or writable layer. That's where the contents will be written. And when you delete the container, that writable layer will be deleted. Image will stay as it was before. Okay. Images will not get modified. It just the container creates one more layer on top of it and does the job what it is meant for. Yes. Hopefully, Aniket, you got the point. Good. Now the time has come to dig around this and start creating our own image because we have done so many things there with the other images. Now we want to create our own image there. We already have talked about that slash where slash lib slash docker. Hostname, we'll talk about this later. That's not that important. Publishing port, I guess I mentioned that right now. With -p, we can do it. Container information, we'll talk about that later. It's not a big deal right now. Network, we are going to see the next week. Today, we are going to see a little bit advanced Docker image because we are in the context of it. So I'm going to share all the notes with you right after today's session. So you will have some points for the next Saturday, Sunday. So you can go through it before the session. So you'll have some more idea there, maybe before we start the topic. So I'm going to share everything with you. Don't worry. Okay, so here we are. And now we want to create our custom images. Now, how do I create the custom image? To create the custom image means like these people have created their images like Nginx, HTTPD, or MySQL, and all of that stuff. They have created their images. I want to create my own. Let's say I have a website. I want to run that inside my another directory. Inside my another container. How do I do that? To do this, we have to create a new image out of it, and this can be created by using something called as a Docker file. So what is a Docker file? Think about Docker file as the file which contains the instruction which will build an image for you. So the Docker file contains a series of instructions paired with the arguments, and those instructions will be used to create your image. That's it. Each instruction should be in an uppercase letter and will be followed by an argument. We'll talk about that, don't worry. Instructions are processed from top to bottom because it's a scripted file. Each instruction adds a new layer to the image and then commits the image. Do you remember what did I say yesterday? Every single instruction is going to create the new layer. And I said yesterday, like today, I'm going to show you the proof. This is what we are going to do now. So every instruction adds a new layer to the image. So we said that images are made up of different layers. Who is the one which are creating those images? Sorry, those layers, the commands, the instructions inside that Docker file, which are creating the layers inside that image. That's it. Layered file system. Yes, Pratik. Upon running, changes made by the instructions make them inside the container. So changes will not be stored or changes will not be committed to the images after you create the container, because container is going to make the changes inside the writable layer. So original image will stay as it is, intact. So that will not get modified there. How do I create my file? How do I create my image? There are a bunch of instructions that we have to start using with, like the from. Maybe from is the one where we can decide the base file, env for environment variable, run for running a command inside the container at the time, inside the image while building it. Command means when the container gets created, we want to execute this one. Expose is the one which is going to expose the port number. Work directory is where we can set the work directory as a directory where we are going to copy the files, or where we are going to put our source code. Add is going to add and copy, both of them will copy some files from my machine to image. Label is just going to say like who's the label, what is the more information or metadata about this one. Maintainer is the one who has created that images, and entry point is the one which is going to get used to execute your image, execute your container, or it sets the goal for that container. Now we are going to use those commands one by one, maybe step by step. So let us do some exercise here. I'll keep that commands.md as it is and write inside this directory, or should I? No, I'll keep that as it is, and better I will start writing the code here. I'm done with both these containers. I'm sorry, I'm going to exit from both of them. Sorry, docker container ls, and I'm going to remove both of them in a sense, nginx as well as httpd as well as mysql. We don't need any one of them. They are eating my memory unnecessary or consuming my cpus. I don't want to do that. I'm going to say force delete all of them. I don't need them. httpd, sorry, httpd. Okay, what the hell? Oh, I called it as Apache. Sorry, my bad. Apache. That's it. So now if I go for container ls, that's the Mongo which is running. That's right. No, you can't. There is another way you can delete all of them. Rubble. We'll talk about that later. So right now, I think like I want to create my own container. I'm sorry, I want to create my own image. So let us see how it can be done. I'm going to go back to the directory which is shared with you. So probably it is in data today. No, where did I say that? Data Sunbeam 2020, I guess, or 2021 workshop. We are in Docker, and we are in the day 2. This is where I created that commands.md. Right here, I'm going to create a new directory. So in your student portal, you will see that right there. I'm going to say images. Okay, and inside that images, I'm going to start with the first image. So mkdir app1. So imagine this is my website. Inside my app1, I want to create a very simple website. A website is nothing but a one single page website. It can be anything, but I'm going to start with a very simple example. So let's say this is the file index.html. This is the HTML file. So this is HTML. I'm going to start with h1 HTML first. So this is going to be a very simple h1, and say welcome to the welcome to the custom image, or welcome to my application, whatever, doesn't matter. Welcome to my application to start with. Okay. So probably I'm going to see that HTML file. So see how it is looking like. I can double click on that and it will open here and it shows like welcome to my application. I hate that font. Wait a sec. I'm going to go back here and say this is going to be the style. I'll say star and change the font family to Arial. That's better. You can copy paste that code from student portal. Okay, don't have to write every single thing on your own. So that looks better. Welcome to my application. Looks fine. I want to run this application, in a sense, I want to run this website with one page index.html inside a container. How do I do that? To do this, we'll have to copy this into my container, but I can't do that unless I have an image which is going to do this job for me. So now I'm going to build my own image. To build your own image, you are going to start creating one file called as a Docker file. I would recommend you to download this Visual Studio Code because it's going to make your life so simple. You can directly start writing the code inside the Visual Studio Code. It's very simple. And if you go to the extensions, there is an extension for Docker and there's an extension for Docker file. Do I have it installed? This is the Docker extension, and I don't have it for Docker file. Not a big deal. I'm going to say Docker file. And there is one extension for Docker file validator. And there is one more, syntax. That's okay. That's fine. So install these extensions in your in your Visual Studio Code, and that is going to make your life a little bit simpler. This is the first one. I'm going to mention that right here. So this is where we are going to say uh, VS, sorry, VS Code, what the hell? VS Code plugins or extensions, whatever you can say. This is the first one, okay? You can use, I'm not saying do it, but I'm saying just suggestion. It will make your life a little bit simpler if you are doing it. So that's the second one. And there is one more. There is one more for Docker validating syntax. Here it is. Docker file system or file syntax check. So it will check everything and it will tell me like whether I'm writing the code right or not. Enough. So let's create that file, Docker file inside it, and then we'll start saying like what and how we can do it. Now to do this, first understand the philosophy behind this, because if you can understand the philosophy, you can create your own image easily. You can create your own image by using a base image. So if I want to create my image, this is where I want to create my image. And if you want to create your image, you have to start with some base image. So there has to be a layer called as a base image, and this base image will be always another image. So this is going to be, you can say, manifest. If you can recall, I mentioned that word yesterday. Manifest means it's the basic version or the basic image you want to start with. Sorry, this is the manifest. Sorry, this is the manifest. So this is the manifest means this is the base image, you know. So your image is based on a custom, your custom image is based on a separate base image. And to say which base image you want to start with, you are going to use that from command. So this is the first command which we are going to use in order to decide which is the base image for me. Now imagine that this is the website that I want to run. Now if I want to run the website, that means I have to have, let's say, Apache installed in it, or maybe Nginx installed in it, whichever you want to go for. So I'll use Apache for now, which means my base image has to have an Apache, means my base image has to be HTTPD. So what I'm going to say here is from, maybe I'm going to say base image is HTTPD. HTTPD is the name of that image. Comments can be added by using hash. I can say this is the base image from which my image will be created. This is the first time we are writing it. I'm going a little bit slower here. So from command will decide which is the base image. Once you have the base image will give you whatever you are looking for. Like if I'm looking for web server, HTTP is going to give me the web server. Now, because it is HTTPD, I'll have to look at the documentation for HTTPD, and then we'll decide what and how we can configure our image. This depends on the base image. Now, because it is HTTPD has said that if you want to copy something, you can, if you want to host your website, then you can copy to this directory. So what I'm going to do here is I'm going to go back inside this and see the command. I want to copy this file index.html to this directory /osr/local/apache2/htdocs. This is what HTTPD is telling me. If it is Nginx, it will be /osr/nginx/layer/html. You know. So the very second command is like copy the file or copy that index.html to htdocs directory. How do I do that? This is the second command. I mean, if you look at the list of commands, there is a copy command. You can use add or copy. Both of them will do the same job with a small difference. So this is the copy command. What is the command? What is the file that you want to copy? Right now on my physical machine, I'm having a file /. In the current directory, there is a file index.html. Where do I want to copy? Inside the container at this particular location. So copy command has a syntax. Syntax is like you will start with a directory or a file on your machine, and this is the destination inside the container. This is your machine's source, and this is the destination's directory, container's destination where the file will be copied to. See, This is where we have decided the base image. This is where we have copied the index.html into this directory. That's it. We don't have to do anything other than that. Next, I mean, if you want, you can say that it's already been said inside the HTTPD, but it's better we can say expose port number, port 80 for listening. For listening for incoming requests. How do I do that? It's again one more command. It's called as an expose, and this expose is going to expose port number 80. This is again one of the commands here, expose. Finally, you want to run only one process, that's entry point or that's CMD, whatever you can think of. I'm going to say this is where we can say run Apache run Apache in foreground. This is the way we should do it, foreground. So this is the CMD. CMD is the one which is going to start the process for which the container is created. So container is created to start Apache, and I'm going to say Apache CTL -d foreground. That's it, foreground. Sorry, foreground. That's it. So run Apache in the foreground. That's it. These are the instructions, and every instruction is going to create one layer within your image. See, from is going to decide the base image. Copy is going to copy the index.html file from your machine to that directory inside the container. Expose is going to expose the port number 80 for listening incoming requests, and Apache CTL is where you see the Apache is running Apache running in the foreground in the foreground mode, so that your container will continue to run. So expose is the command which is going to expose port number 80. Why am I exposing port number 80? Because my Apache is running on port number 80. If it is my server, then my server will run on 3000 port, for example, then I will say expose 3000. That's how we are going to do it. I'm going to show you a couple of different examples. This is the simplest example for every one of you. I know few of you are coming with JavaScript knowledge, few of you are coming with Java knowledge, few of you are coming with Python knowledge. So I'm going to show you a couple of examples so you can see Docker is technology neutral. You can use any language and you can run that code inside it. I'll show you a couple of examples one by one. This is a very simple example. I want to create a very simple website. I want to create a very simple image to host my website there. So this is a Docker image, a Docker file I've created. Now I want to build an image there. So how do I build my image? This is again image specific. So I'm going to go back here and say this is where we want to build our image. How do I build the image? This is a Docker file I've created. To build the image, we are going to say, go to that directory where you are creating that Docker file and say Docker image build. Before that, I'm going to say ls just to make sure how many images we are having. And now I'm going to create one image by saying Docker image build -t for tag, whatever name you want to give there. I want to say this is going to be my website. This is the image name, my website. Dot means current directory. You will find the Docker file. If you want to say if you want to specify the name, you can say -f Docker file. But because the Docker file name is Docker file, you don't have to say that. You can say dot, and it will find the file name automatically because we haven't changed the name. It's still capital D Docker file. Enter. See, it has built the image, and probably if I go back and say Docker image ls, you see my website has been created 8 seconds ago. So it just have created that, which is almost like 130 MB. That's it. This is the command Docker image build -t, whatever the name you want to go for, dot will create this one here. So probably guys, if you are writing code along with me, this must have given you an image. So if I run that code again, see, website is my website, image is ready. That's it. Guess what? Now you create a container out of it. Run with port number 80, internal container port, and run on your any port number for your machine. Port forward it and see what does it show. Check this out. Docker container what? Run -itd -p. I'm going to use the port number 8080, doesn't matter. Minus minus name, my website. It's the name for my container, and my website is the name of my image. I'm going to create this container here, and because it is running on port number 8080, if I go back and say localhost port number 8080, last time when I ran that HTTPD, it gave me it works. Do you remember that output? It works. But now if I say enter, this time, what the hell? Am I running it with HTTPD or my website? It's my website. It's the cache version. Can't help. This is the cache version. I'm going to do it one more time and say refresh. And you see, this is welcome to my application. That was a cache. Just say control refresh or control F5 or control R, and you will see your application is running inside the container. Guys, yes, Robin, it's working for you. Very good. Mohit, it's working for you. Very good. I need the confirmation, like whether you are getting it or not. It should work, but see what happens there. Failed to solve with the front end Docker file video. Failed to read the Docker file. Open blah blah blah. No such. You are running that code in a wrong directory, I guess, Prabal. So see where you are. You are executing that command inside that directory where you should see the Docker file. So Docker file should be there inside that directory where you are executing this command. Otherwise, it won't work. Working, Kuldev. That's really great. Harshit. Apache CTL is not found. Apache CTL spelling is wrong. Not Apache ATL. It's Apache CTL. So copy paste the code if you really want to. Harshit. It's Apache CTL. Amit, your question. Show your terminal. That's what my terminal is. So this output might be different for you and for me. It doesn't matter. What matters is whether you are getting the image or not. Aditya, base image that we are using should already be pulled it, or it will pull on the fly. It will check. If the image is already there, it will use it. If it is not, it will pull it, and then it will create your image. I mean the base image. So it will pull the base image if it is not already there, and then it will build your custom image. Okay, Aditya, that will be again automatically being checked behind the scene. I'll wait for you. No problem. Correction refused. You didn't use the correct port number, I guess. Amit. Working Harshit, that's great. Robin, where the command we have in the Docker file will create a separate layer. Every single instruction I gave, this instruction, this instruction, this instruction, and this instruction will create a separate layer. Look at this, Robin. If I go back and say Docker image inspect my website, this is the name of my image. If you look at that, I'm so sorry, you can see there are different layers, but if I use the history command, I can see what are the different layers within it and how those layers have been created. Till this I think we are using the base image there, so this is where we are running the last command, Apache CTL. Remember, I'm going to put this one here, and probably you can see that, or you can compare that side by side. Check this out. I'm going to run this command one more time. So see this. I'm going to come back here and say this is the the last command. Last command will be always on top. This is the last command, Apache CTL foreground. This is the last layer you can see here. Okay. You can see this bidder. So this is the last layer. It is going to run the Apache CTL in the foreground. This is what we have said. We have exposed the port number 80. Here it is. Expose port number 80 here. Then there is a layer copy. There is a layer here. What is it doing? It's saying index.html copy to this one. So it has created one more layer and it has copied that file from here to there. After this, whatever you see here, this is coming from that HTTPD. So HTTPD is giving me all of that stuff there. So probably Prabal, now hopefully you can understand like how those images are getting built behind the scene. Every single layer is created by every single instruction right inside your Docker file. Okay, so that's how we are going to do it. Okay. Robin, I think, not Prabal, sorry. Robin, I think you must be getting it, right? So next time if we add any instruction, it will take a lesser time to build the Docker image. Absolutely. Next time it is not going to do every single thing again and again because the layers are already there. It is just going to create a new layer after it and then it will do its due job. Exactly right. Okay. Unable to create a symlink in the Docker file. Mayur, look at the directory in which you are executing this command. Docker file should be in the current directory. Yes, that's important. Aniket, you always need to use the base image. Yes, you always have to use the base image to create a custom image. That's mandatory. Aniket, so you need to use the base image. Yes, you have to. Robin, why the extension of Docker file is .tar? No. When did I say that? There is no extension for Docker file. You should not use any extension for the Docker image. Docker image. Docker image is the one which is, see, there is a funda behind this. When we are creating our custom image, we are using some base image. But imagine how these people have created their own image. They have already added the base file in terms of tar, and every single one is going to get shrinked together or archived together. It's not only a tar, it should be tar.gz, precisely, Robin. So it's kind of archived and compressed version of every single layer. It will get expanded whenever you are creating a container out of it. So Robin, it's not only the tar, it should be tar.gz. Okay, so if you go to the slash var slash lib slash docker, you will find it there. Okay. Sachin, copy index to do copy field forbidden outside the context index or HTML. You are not running that inside the same directory. Look at the hierarchy, guys. The hierarchy should be like this. Within your current directory, you should have the Docker file, and next to it should be the index or HTML. Or you just go back to the directory and say ls. Make sure that index or HTML and Docker file are there in the current directory, and then execute it will work. Okay. I have Docker file in the directory called Docker instead of the same directory. No, it won't work. So you have to have both of them in the same directory. Okay. Yadnesh, sending the build context to Docker daemon 4.92 GB. Why is it happening? I'll mention that later. This is how we are going to optimize it by using a Docker ignore file. We'll talk about that later. Right now, it's okay to send all of these things there. It's perfectly all right. Don't worry about that right now. There is something called as a build context. With this, it is going to create the context and then it is going to build your image. By default, it's going to bring every single thing. You can ignore a few things there. How? We'll use a Docker ignore file later. It worked, Aditya, right? Very good. See, guys, this is the way you are supposed to do the job. Let's do one more time. This is not the image I want to build right now, or this is not the website I want to build right now. Let's do something else. Or maybe I'll show you one more example and then we'll go to the next one. Imagine I have kind of finished my first version of my application and I gave this application to my client. My client gave me a suggestion like, color is not looking good. So can you just change it to red? Fine, I'll do that right now. Watch this. I'm going to go back here in index of HTML and probably I'm going to change the color of that H1 to a red. So how do I do that? I'm going to say, I'm sorry, color, what the hell? Color should be something like a red. So I'm going to change this one. I will see that change right inside in my machine. See, this is where I'm using the file protocol and it works. But if I use that container, this is not the website now, this is the container. If I say refresh, and even if I keep on refreshing for the rest of my life, this is not going to change the color. Why is it not going to change the color? The reason is very simple. It's not having the change yet inside that container. So how do I put that change? You can't. You have to modify an image for that. You remember, containers are immutable. Once created, you can't change anything there. So if you want the container to have an image or have that HTML file with red color, you have to first destroy the color, have to destroy the container. We have to create new version of your image and then you have to build a new container out of it. See, this is what we are going to do now. Check this out. I have to stop that container. There is no option. Docker container ls. This is the container that I want to stop. So Docker container rm, what's the name? My website, So this is where we are going to say my website minus force. I'm going to delete that container. because unless the container is deleted, you will not be able to create a new container or fresh container out of that new image. The image which you see right now, this image is not having the change related to that red color, so we'll have to build a new image out of it. So I'm going to say docker image rm my website. Delete that image first and then use the same command, docker image build, okay, -t my website, I'm sorry, my website, I'm sorry, dot, that's it. See, my website is now created. I'm going to create a new container out of it. The container which we have created earlier, I'm going to create it now. And if I say refresh, then I'll be able to see that color change. Oh my God. So does that mean with a simple, even a single line change, I have to destroy the container, delete the image and recreate the image and then recreate the container? Yes. Are we supposed to do it every single time? Yes. So are you not wasting your time? Of course, I'm wasting my time doing this. Isn't there any better option? Of course there is. What's the better option? Jenkins. Jenkins or CI/CD pipelines are going to do the job with this simple change. Now, not the volumes and storage, Akshay. This is a better, I mean, this is a kind of this is the kind of a different requirement. For volume and storage, we generally are used for, I mean, we generally use that for storing the data, not for, see, these files are changed on my desk and they will be there in that image all the time, not like we are collecting the data from user. This is the file, that's a static resource, so you can't expect that volume and storage there. You have to put that right inside the image, and that is where the CI/CD pipeline will come into picture. Okay, Robin, as we are building our own custom Docker images based on custom some basis, let's say we have to start, we have started the container and it's running fine for some few days, but let's say sometimes there are some upgraded version of the base images released in the Docker, then how will we update your so you are saying like today you are using HTTPD version, let's say 2.4, and tomorrow if 2.6 is released, how do I use that? You have no option. Delete the container, update the image, create the new container. That's the only solution you are having, Robin. Containers are immutable. That's what we said earlier as well. That's what you are kind of getting a, maybe you can say downside, or maybe you can say that's how it is going to work. So Robin, to make use of later version or the latest version of that base image, you have to literally delete the container, delete the image, or maybe create the new version of image and recreate the container. That's how it is going to do the job. Okay, great. Guys, I hope you are there with me, and if you are able to see that image, updated image, so probably that means everything is going good. Great. I think we are done with that example. So there is no point keeping that container and the image running on my machine. So I'm going to say remove my website minus force. And should I show you this? Let's show you this. Not a big deal. Anyways, we have to do that later one more time, but we'll do that in a private repository. Now, what happened here, guys? Look at that. This is a little bit different. Watch this. What happened here is, imagine that I'm a developer and probably maybe there is a team sitting, maybe there is a tester team, a testing team who is sitting or who's waiting for me to send them the new application, and my application is now containerized. So how do I give this application to them? Because now the image is there, fine, I can create a container out of it, still fine, but you know what, this image is available only on my machine. How the testers guys will get the image from my machine, and how will they create the containers on their machine? That's something I'll have to do it. How do I do that then? Any guess? How do I do this? Aditya, I know this is not the right forum, but on a query on Jenkins, can Jenkins check the changes per project and multiple repos inside the project? Yes, it can. It can. Yes, so absolutely right, guys. If you want to solve this problem, there is only one option. We have to put our image inside that Docker hub. And that's where I want to show you how to commit your images so that I can share my images with the rest of the world. To do this, go back to the Docker hub and create your user. My user is already there. It's Python CBP. So you create your own user. It's free of cost. Just go and maybe create your user and be ready with it. Now, my username is Python CPP. So we have to create a new version, not version, but I mean, the better option is to say you have to rename this image with something like this. Say Python, I'm sorry, the Docker image. This is where we are going to create a tag. Tag means we are going to give another name to that image. It's like alias, for example. So I'm going to say my website is my website is the name of that image. I want to create the tag like my Docker hub username. My Docker hub username is Python CPP slash whatever name I want to give to that image. I'm going to say my website. So the first step is to go for creating a tag version. I'm using Python CPP slash website. That does not mean you should do this. Use, let's say, Docker hub user name. Okay, so that's how we are going to do the job. Okay, so this is where you are going to use the Docker hub username, and probably now I'm going to go for again Docker image ls. You see, we are having exactly two images. See this, those two images are same. You see the IDs are also same. It just we have renamed that, not renamed it. I've created one alias of the same image with something like this. Now, why is it needed? This is the way Docker hub works. In the Docker hub, if you want to push your image should be having a name in this format, your username slash the image name. Now, how do I push it? To push it, we'll have to use a command docker login. In my case, I already have logged in, I guess. I'm going to log out first and do it together. So this is login command. So when you say docker login, it will ask you the username. Mine is Python CPP. It will ask you the password. I'm going to enter my password. And once you enter the password, it will allow you to push your images. So this is where we are going to say docker login. Okay, so Docker login, and finally I'm going to upload my image. To upload my image, I'm going to say Docker image push your image. Which image? Same, the one which I just created, Python CPP slash my website, and wait and watch. It's going to upload your images, not the entire image, but the only change the layers. This is again layers. See this. I have created that image with 4 layers. It is going to just push only 4 layers. The fifth one is already available on the Docker hub. That's the beauty of using layered file system. Do you see that? Out of that image, if I go for the history, Docker image history, if you are with me, you can understand what am I trying to show you here, my website. So if you look at the history, this is a new layer which is created by me. This is the new layer created by me. This is the new layer created by me. But after this, this is the base image. The base image is already there. So 69.2 MB is already there. So if I want to share my image, all I need to share is 1, 2, 3, and 4. That's it. The 4 instructions or 4 layers. Rest of the layers are already there. So it says mounted from this because they are already there, and it has just pushed only those changed layers. Guess what? If I go back to my website, for the Docker hub again, I'm already logged in here. So maybe I can go for my content or simply my profile, whatever you go there, and you will find it private repositories. I'll do it one more time. And you see that a second ago or minute ago, I have pushed my image, Python CPP, my website. So guys, look what I'm trying to show you now. I'm going to delete both the images from my machine. So Docker image ls, I'm going to delete both of them. Docker image rm, Python CPP. I'm going to delete that right now. Python CPP slash my website. And I'm going to delete my website as well. See, I have deleted all the file, all those images there, which I created earlier. Now I want to use the image which I uploaded to this. Imagine that I was developer earlier. Now I changed my hat and I'm a tester right now. So the developer has given me an image, Python CPP slash my website, and I want to try it on my machine. I'm a tester. How do I do that? To do this, I'm going to go back here and say Docker image pull. You can pull this image saying the name is Python CPP slash my website. You can do it on your machine as well. So try this. You can see the same application which I've just created right here. So this is my website. You see, now if I say Docker image ls, it's already there. I'm going to run a container out of it. So I'm sorry, container. This container is going to have a name run, let's say my website. Again, I'm sorry, my website minus p. Let's use a different port, 9090, port number 80. And what's the name? The name is python cpp slash my website. It will create the container. Oops, I forgot to say minus itd. I forgot to say that. Not a big deal. There is an option to stop that container. If you forgot to say minus itd, the control C will not work. So better you go to the second command or second command prompt and say docker container ls. See, this is the one which is running my website. You want to stop it. So I can say docker container stop my website. That's the only option you have. And then it will stop that command prompt as well. It is still stopping. Will take a second or two. Finally it stopped, and you see I got my command prompt back on this command prompt on this terminal as well. Anyways, I'm going to stop and I'm going to remove this container as well, my website. And let's recreate this. And when I say recreate, I think I'll have to supply the parameter minus itd. What the hell, I didn't ask you to run this. I just wanted to go to the previous command, will take some time. Okay, so image pool, what are you doing here? Downloaded newer image. Absolutely, that is working fine then, Sharendra. That's really good. Images can only be uploaded to the Docker Hub or any repository will work. Right now, we are having only one repository, that is Docker Hub. Later on in the last session, maybe on next Sunday, we are going to see something called as the EE, where we will create our own DTR, Docker Trusted Repository. That's where we will create our custom repository. I'll show you how it can be done later. Okay, here I want to put that minus itd. So now it will start running, and hopefully it is running on port number 9090. So 8080 won't work. We'll have to go for 9090 run, and something has gone wrong. My website is already having a container. Sorry, my website is already running, I guess. Sorry, we'll have to remove that. Container rm my website. Now let's create the container. Let's refresh it, and boom, I was looking for that image. I see that it's really working fine. Yes, welcome in the red color. Absolutely, it is working fine. You see. So what have we done? We have created our own image. We have uploaded that to the Docker Hub. We downloaded it again from Docker Hub. We created a container, and yeah, everything worked fine. Really fine. So how Docker engine trust that it's downloaded from image from trusting. I'll talk about it towards the end of it, towards on the next session, next to next session on Sunday, because there we are kind of discussing how the DTR works, how the MTLS work. Yes, security portion. Absolutely, Shailendra. There we'll talk about it. Okay, because that's one of the domains, so we'll have to understand that. It's not like we just have to talk about it and we'll have to leave it. We'll have to create our own repository. At that time, I'll mention what is the architecture behind it. Okay. Did it should pull image automatically, but it is not. Of course it will. Maybe look at the username you have used. I don't know whether it is really the correct one. Let me give it a try on my machine. Oops, not that. Copy, put it here. So Prabal, I think this is what your your machine, your username is. I guess it's not available locally. It is going to download it. If it is available, it's not available. So check this out. Maybe this has not got uploaded properly, or maybe it's not available there. Just go to your Docker Hub account and make sure that you can see it there. So if you just click on that Docker Hub again, after logging in, you will see that image here. If you see that, only then you can download it here. It pushed to my repository. That's Can you see that right here on your machine? If you go to this Docker Hub, name is website. Now, exactly. Then you'll have to change it to my website. Sorry, website. That's it. Hence, it was not working. Exactly. See, it is downloading it now. See, I'm also downloading it. It already got downloaded and it is running on port number what? 8081. So probably if I go back and say this is going to be localhost, sorry, local localhost 8081. Something is gone wrong, I guess. Something has gone wrong, I guess. Oh, my website is already there. Sorry, it's not you, it's me actually. We'll have to delete that container. Stop, or maybe I can say rm my website minus force, and then we can run this right here. So Prabal, this is your image. If I say refresh, blah blah blah. This is what you said. Whatever it is, I don't care. So this is what you are getting it there, right? Yes, Shailendra recommended extension for Visual Studio Code. I already have mentioned this Shailendra here. So probably if you just go to that commands.md file towards the end of this, I already have added the recommended extension. So with that, it will make your life a little bit easier. Okay, you can install it right away, or maybe you can install that later. Not a big deal. I'm going to share that file with you. You can look at the student portal and you can copy paste the links as well. Robin, what is the use of namespaces in Docker image, and where we can see how it is being used in our own created Docker image? Namespaces are not the concepts that you are supposed to use. Namespaces are the concepts which are used behind the scene by the Docker. This is not the Docker's concept, this is the Linux concept. So you can use that there. So that is the one which you're talking about from the Linux point of view. Okay, Robin? So this is something which is used behind the scene by Docker, not you in your Docker file. Okay, so I gave you a simple example of a website here. Now let's go for one more example where we want to run a Java application. Okay. I'm sorry. For Java application, we need to first find out which is the base image we should go for. So hub.docker.com, and if I search for Java, I should get OpenJDK or maybe Oracle JDK. I think it's better we can go for OpenJDK. Which version should I go for? OpenJDK 7. No, I think OpenJDK 8. I want to go for this one here. Let's go for this and see how we can build our own image with the OpenJDK 8.0. Okay, so I'm going to go back here, create a new directory app2. This is the Java example. So right inside this app2, I'm going to start writing the code. Going to be a very simple example, but see how simple it is. So here I'm going to create a new file. Let's say test, or maybe let's say fine, test.java. Now this is the Java file. Maybe I can say public class test, has to be same name as out of the file name. Again, it's going to be public static void main string args array, and again it's going to be system.out.println ln. I'll say welcome to Java application. That's it. This is a very simple example of it. Okay, so this is the one which is which I want to run inside the container. So how do I do that? To do this, I'm going to create an image out of it. I'm going to say the Docker file again. Okay, I guess I have OpenJDK on my machine because Docker image ls OpenJDK. No, I think I have not installed. I think we want to first remove those containers. I don't want to create unnecessary mess with that. It's not needed. So I'm going to say my website minus force because it's running. Good. I want to delete that image as well. Image rm. I'm going to use a shortcut 37DA. So instead of writing the name, I can use the ID and get them both deleted. Docker image ls. Docker image ls. I think that's it. Fine. So now I'm going to use that OpenJDK. So that's from OpenJDK 8.0. That's why I'm going to use a separate version or a specific version 8. Okay, this is the file test.java. So where should I copy it? I'm going to say copy it anywhere. Now before I copy it anywhere, I'm going to use one more command called as work directory. So here I'm going to say base image. We talked about that last time. Work directory means this is the directory where you want to copy the code. So maybe I can say there is a directory called as /src. This directory will get created automatically if it doesn't if it does not exist, and then we can say copy, let's say copy test file to /src. You can do it by saying copy dot slash sorry dot slash test dot java to dot. When I say dot here means it is a work directory, because I said that whenever I say current directory, it is always going to be /src. So when I say dot, it will by default go to /src. I don't have to keep on saying /src all the time. I can say dot, and the dot will set test as a work directory. Or maybe I can say set the current directory to the /src. That's how we can say the work directory is equals to /src. Now we are having that file copied there. I can simply execute the command in the sense I'm going to do it in the container, not inside the image. So image will be just building there, but when the container gets created, I want to create that, or maybe I can run that inside the image while building the image. So I'm going to say run the command, or maybe compile the code while building the image. So there is a command called as a run, and there is a command called as a cmd. I used the cmd earlier, if you can recall. Cmd is used to run a command when the container is starting, and run is used for executing a command at the time of building the image. So I want to compile that code by saying, let's say java c, name of that file is test, or maybe I can say dot slash test dot java. That's it. This is the command that I want to execute at the time of building the image. So it will create a file called as test.class, and then I want to run this inside the container. So maybe I can say run the java class, maybe inside the container. So look at the difference between command cmd and command run. Run means it will get executed right at the time of building the image, and cmd will wait till you create the container, and this command will run inside the container. What do you want to do here? Nothing. I just want to execute that java file by saying java test. Means it will execute the test.class file. No, it will not execute it from the host machine. It will get executed inside the image. I mean, from the host machine in a sense, it will not be like a host machine is going to execute it. It's going to get executed for the image while building that image. It is going to create one more layer inside it. Check this out now. This is the image. This is the Docker file I wanted to create. Let's see what happens now. Again, the same command, docker image build -t. I'm going to say my Java app. Why my? Now maybe you can say my app better. Dot. So this is where we are going to create a new file. You see, it is building this file. It is downloading that OpenJDK 8.0. It has converted. It has kind of compiled that test.java. It has not executed it. It has just compiled it because it has already executed that instruction java c test.java. Means .class file must be already there. Now to execute that, we'll have to create a container out of it, and I can say this is the container. Excuse me. Docker container run --itd. Should I say itd? I don't have to, because that's only one command it is going to execute and it will go away. It's not going to run continuously. It's just going to execute that command. It will go away. Check this out. Instead, I'm going to use --rm. Hopefully you can still recall. --rm means once it is done the job, I want that container to exit. So --rm. If you want, you can, name is not going to matter here, because you see, it's going to execute this and it will just go away. When I say run, look, it has executed the code. Welcome to Java application, and it has done its job. See how simple is that? So probably what did we do? We wrote our code here, maybe here, and then I copied that file inside my OpenJDK image, and then I converted that, or I compiled that to test.class, and then when the container is starting, at that time I executed that Java file, Java test, and yes, it has executed it. And after that, there is nothing to do, so container got exited. And because I used minus minus rm, if I say docker container ls minus l, I'm sorry, ls minus a, you see that the container is not listed anywhere here. That's how you are getting it. Containers will be executing the cmd command. Exactly, the container will execute the cmd, image will execute the run. That's the difference between them. Hosting for Java in the sense what? Java web application, it's exactly same. Just use the base image, different than Apache. That's it. You can use a Tomcat there or JBoss there. Unfortunately, Praveen, I don't like to develop the web applications using Java. Literally, I hate Java, by the way. That's the reason I don't use it. If you want to, I mean, that's the reason I can't show you that, because I don't know how to do that, because I really don't want to learn that. That's the reason. So probably you can just use the base image and you do the job. So sad, but this is how it is. In fact, I hate personally, I hate Java. I use, it's only for Android I use Java. Otherwise, I don't use Java at all. I hate it. I mean, I use Kotlin a lot these days for Java. Sorry, for Android. So Java is something I want to forget. Anyways, Praveen, can you please show? Okay, so probably you will see that it's just exactly similar thing. If you get one thing, you can always get the other thing automatically. Okay, what is the user command in Docker file? There are many commands. We will see them one by one, step by step. Not everything is needed in one single day. So Kalpesh, wait, there are a couple of more commands we have to see. There is a entire optimization remaining. So how we'll optimize the file size? Because you know what? If I look at the Docker image ls, a simple hello world, can you imagine a simple hello world is having 514 MB? Imagine a user is going to download the entire 514 MB just to say, welcome to my application. Now, this should not be the case. There should be some better option to solve this problem, to optimize the file size, to compress the file size. And yes, we are going to do that. Next weekend, we are going to do that. Security, optimization, networking, and EE, 4 topics. Two on Sunday, two on Saturday. We'll finish them there. Okay, one last example, and then we'll call it a day. So probably I showed you Java, I showed you a HTML, I'll show you a Python application as well, because I love Python. I hope DBDA people are there still, and they will at least like to see that. I'm sorry, I'm searching for Python. So this is the image, for example, I want to go for, and I want to run my Python code. Very simple, a simple hello world application there. I want to run inside it. This is the Python I want to use here. Okay, so how do I do that? Similar things again. I'm going to go back here. First, let's delete that, delete container already got deleted. My app is what I want to delete first. So Docker image rm my app, I'm going to delete, I'm sorry, I'm going to create a new directory, mkdir app3. Let's go back to the app3. Let's open a new Docker file. First, write a simple application. Let's say myapp.py, that's Python. As simple as that. Print hello world in Python. Very, very, very simple. That's it. I want to run this code. How do I do that? Same old story. Again, Docker file is needed. We have to set the from, and then I'm sorry, from, and say from what? Python colon 3.x. Wait a sec. Let me see the tag which is written somewhere here. Which one should I go for? I think 3.8, 3.9, 3.10. Which one is the latest pointing to? So let's see the latest. The latest is pointing to 3.9. That's okay. I'm going to use only Python. So by default, it's going to use 3.9. That's not a big deal. I'm going to set the workspace or work DRI to /src like what I did last time. Then copy, let's say ./myapp.py. Is that the right file name? Yes, that's the right file name. To dot means to /src. And finally, I'm going to literally run that inside the container, cmd python 3, and the name is ./myapp.py. That's it. As simple as that. So let's build an image out of it. I'm going to say Docker image build minus t my app dot, I'm sorry, dot is the file name. It's going to build it. What the hell? Python was there? I don't know. I didn't expect that. Python image ls. How the hell is possible? Exporting to this, exporting layer. Where is Python? I'm surprised. Let's see what happens here. Docker container, and I'm going to say minus minus rm. I want to delete this. I'm sorry, rm. As soon as it is done the job, I'll say my app. Oops. Docker container run. Who will say run there? So run blah blah blah. Oh, it is still referring to the older one. Sorry, there is no option, guys. We'll have to stop this again by saying docker container ls, docker container stop. This is my app, so 27 minus, or say rm minus minus, I'm sorry, minus minus force 27 is the id. I think it's gone. It's gone. Now let's remove that image. Docker image rm my app got removed. Docker image ls, my app isn't there. I'm in the right directory, right? Very good. Now we'll say docker image build minus t. Now I can say my app dot. Now it will build it. That's what I was wondering. Last time the image was exit, exit. I'm sorry, the image was there. That's the reason it could not create that image again. But now it is building it. That's what I was wondering, like how come Python has not been downloaded? Because Python has not installed on my machine here. Great, it got installed. Very nice. Now I'm going to go back and look at that image, Docker image ls. I'm going to create a container out of it. Container run minus minus rm, name is my app. Hello world in Python. As simple as that. Is it mandatory to have the work directory layer? No, you don't have to. You can say something. My work directory is not going to create any layer for that. It's just going to set it. So if you don't want to do it, see, this is how you will have to do that. /src /src /my app. So you can save this layer here. I'm sorry, you can save this layer here, you know. So if you don't want to do it, that's another option for you. Aditya, this is the reason I don't want to use that src all the time. That's the reason why we are using the work directory. Okay, so the better option is to do this one here. Sachin, can you please explain about the work directory again? Work directory in the sense, I'm just letting my Docker file know that whenever I say dot in the container side, dot means start with /src. That's what am I saying here. So work directory is kind of an alias where we are saying my current directory is /src. Whenever I say dot / my app, where will it start from? It will start from /src. You are setting it a kind of, you know, CD file. So you can say CD into this and do execute all the commands by using this dot /src. That's what it is doing the job right now. Local path, you can say, exactly. Local path of not your machine, local path of container, by the way. Sachin, src from Linux file system. No. It can be anything. It can be, let's say, my app code, whatever. It doesn't matter. It's just a name of the directory. It's not like src from Linux or something. It's the source code file or app source code or simple source code. You decide. Doesn't matter. Just the name of a directory. That's it. Okay. Okay, so I think the container was executed very good. I'm going to delete that image now. Image rm, what's the name? My app. Now that's like I've cleaned my slate now. Yes, that's okay. So hopefully my slate is clean, and I guess we are kind of done with the images, how to create them, how to push them to the Docker Hub, how to create the containers, how to publish the port and stuff, how to expose the environments and stuff like that, you know. What is minus t? Minus t for tag. We are giving a tag. Tag means you are specifying the name for that image. T for tag, Prabal. Okay, so t is nothing but you are giving it a name as my Python. So that's what you are saying. T for tag. Okay. Docker Compose is something different. Yes, we have to see that, but it's not there in your so-called exam. So we are just going to see a quick introduction to it. It's not there in your so-called exam from the DCA point of view. So we'll just see a small example of it. This is needed when we are going for, let's say, a kind of microservices architecture. So I'll show you a simple example there. Okay. Okay, I think that is it, guys. So today we have seen many things. Hopefully, you will get a chance to look at the video and to do the practice in upcoming days, so that on next Saturday, Sunday, we all will be on the same page and we'll do some advanced stuff. Okay. Will you be getting the recording? Of course, yes. You will get the recording and the documents right after the session. Of the topic, which theme are you using for Oh My Z Research? It's Power Line 10K. If you're interested in that, if I look at the Z Research, this is, I'm sorry, my bad. Z Research, what the hell? RC. This is Power Line 10K, exactly, power level 10K. So if you're interested in that, just set this one, install this and set this one. Who's that, by the way? Sachin. So it's a power level 10K. I love that. I mean, since beginning I'm using it. When Powerline 9K was introduced, 8K was introduced, 9K was introduced, 10K was introduced. So I'm using it since ages. I love that thing. Love that thing. Jagdish, what are you saying? Docker and Kubernetes are the sufficient to get the industry to need or to need to learn DevOps tools like Jenkins. Actually speaking, you need to get at least one tool from different world. One tool from containerized, one from the orchestration, one from CI/CD, one from managing the nodes, one from configuration management like Ansible and stuff like that. So at least these things are needed. You know. Harshil will have a quiz this week. Yes, I'm going to send a quiz details and we'll set some questions as well. Any plan for Jenkins? Yes, we have a plan. Right after this Kubernetes, we will plan for Jenkins and see how many people are interested in that, and accordingly we'll decide whether to go for it or not. Okay, not a big deal. Prabal request for Jenkins and Ansible course also. We already were thinking of that, but people are so hesitant to go for Jenkins. They seems like it's pretty much simple, and this is something we already have conducted two batches or three batches earlier. So I don't know how many of you are interested. If you are interested, we definitely will go for Jenkins as well. And Jenkins is again one of my favorite things. You know, Docker, Kubernetes, and Jenkins is something which I love because they are kind of a trio. And of course, there is OpenShift and there is an Ansible as well. We'll see that. Angular, today only we finished it, Mayur. Today was the last day. Earlier today morning we finished it, Mayur. Angular batch. Yes, no problem. Let's finish this Docker and Kubernetes and we'll talk about the Jenkins, Ansible, and OpenShift. Anyways, we'll see. AWS, we finished this 2 weeks before. So probably it will take another couple of weeks for us to start with the new AWS batch. Okay, Sachin? Okay, so I think guys, it's already a bit late. So for you people, so I think it's better we can take a leave and then we'll continue our next one. Azure, hey, it's work in progress, work in progress. So I'll let you know, Shalinda, once we declare that Azure. Okay. Okay, so I think let's call it a day, guys. Thank you very much for attending today's session. I hope you must have learned how to deal with the images and containers. Please practice as much as you can because next Saturday, Sunday, there'll be some advanced topics which are based on whatever we have seen earlier today. Okay. Again, one more time, thank you very much. And please practice it. I'm going to send some quizzes this week and probably I'm going to put the doc file and every single thing on your Git repository. So you send your Git repository details to or put them in your student portal, you will receive a invitation on your GitLab account. Create a GitLab account and update that on student portal, and you will receive the GitLab repository invitation. Accept it, you will get every single thing. Okay, I'll see you on next Saturday exactly at 7:30. If possible, I'll send you invite a little bit earlier. If you are up for little bit before the time, let's say 7 o'clock, I think that will again probably will give us more time to explore some more topics. Again, if and when needed. And again, if you all are okay, we'll start 30 minutes before. We'll start at 7 o'clock. I don't want to go alone after 11 because many people are having some, the another day shift or they are working people. So I don't want them to disturb their night time. I'm a crazy. I don't want you to be crazy too. So we can start maybe 30 minutes before, and we can start with 7 o'clock. So probably we can, we can cover a little bit more topics. So probably 7 is fine, right? I'll send you invite at 7 o'clock. So probably next Saturday and Sunday we'll start a little bit earlier, 7 o'clock, and then we'll see how many topics we'll be covering there. Again, thank you very much. I'll see you on next Saturday. Till then, bye bye. Have a very
Amit,
good day ahead. Oh, sorry, a very good night ahead. And probably, please practice as much as you can. Be
Amit sir.
okay. See you.
Hello, Amit sir.